Hello students, very good morning everyone. Welcome once again to Om Institute and welcome to this important session for control systems. One of the conceptual and very important topics is the Nyquist plots and Nyquist stability criteria. Both will be covered in today's session. Of course, we are going to discuss both the ways. What do I mean by both the ways? How about sketching of the Nyquist plot, and of course, automatically polar plots will be covered with that. And then secondly, what is the stability criteria, stability analysis criteria using the Nyquist plot, right? Very good morning everyone. Come on, quickly update all of your friends that the session is live. Good morning Venu. All right, very good morning all. Good morning Veen Kumar. Good morning Samukha. Okay, let's get started. By the time others will join. Good morning Nelson. Good morning Soumya. Okay. Okay. Just a second. Okay guys, so let's get started with the session. Let's get started with the first question. Before going to the first question, important update for all of you. Yes guys, the Om Institute brings to you the online scholarship test for all the courses, online courses, okay, live and pre-recorded both, for GATE 2027 and 2028 preparation. Yes guys, on the next Sunday, that is 25th of January at 6 p.m, a 50 minutes examination is going to be conducted, and based on your performance and merit in the examination, you get huge scholarships. That is, if you are in the top 3, you get even 100% scholarship on our online courses, and based on your rank, you can see the discounts are mentioned. The syllabus is mentioned here. Fundamental subjects only have been taken. 5 very fundamental subjects have been taken, okay, because you know this is for those who are planning to prepare the GATE preparation, so we don't want to test you very rigorously, but on the basic fundamentals only of your engineering. Okay, the registration is required. You can just scan here, just scan the QR code and get yourself registered and appear on this examination on 25th of January. It's online examination. You can appear on the app as well as web at any place. Okay, the details are mentioned. Okay. Okay guys, the first question, polar plot for GSHS equal to 1 upon S1 plus ST. Now you see, okay, let's start with polar plot and then we will complete to the Nyquist plot. Okay, we'll go step by step, and then after the sketching part is done, I will take up the stability criteria as well. You know, given any Nyquist plot or after drawing the Nyquist plot, how do you assess the stability? Okay, so I have carefully selected 21 questions so that more or less your Nyquist plot is complete. Okay, so again, this is a practice question based session. I'm not going to derive, but still going to explain you how to solve the questions. That much will be there. Okay, but only thing is how that Nyquist stability criteria turns up. Okay, how this concept of Nyquist or polar plot comes up, all that derivation will not go, and I think that's not required also, because just less than 1 month for the examination, so your target should be solving more number of questions and approach. Okay, now see, I'm talking about the polar plot, where we all know that polar plot will be the plot of Gj omega Hj omega, the frequency response, okay, of the open loop transfer function. Okay, Gj omega Hj omega for omega greater than 0 for positive frequency. Okay, for positive frequency. Now, firstly, let me convert this. Before I give you the shortcut, let us understand, okay, one calculation here. What is Gj omega Hj omega? Gj omega Hj omega here is 1 by j omega 1 plus j omega t. Correct. Now, Because it's a complex function, you can have two different approach of understanding the plot. One is converting to the Cartesian form x plus jy, one is converting to the Euler form, that is magnitude and phase form. Okay, so now see, if I have to write down in the x plus jy form, there are two things I will start doing now. Number one calculation, see here, gj omega hj omega, okay, I'll start from here only, already this is written, is equal to, now what will I do? Let me rationalize this. Okay, let me rationalize this with 1 minus j omega t, converting to the Cartesian form, 1 minus j omega t upon j omega, 1 plus j omega t multiplied by 1 minus j omega t. Okay, divided and multiplied by the conjugate. Okay, now, if you see here, this is going to be actually converted to real, x square, a square minus b square. Okay, so 1, but minus b square, j square will be further minus 1. So this will actually become 1 plus omega square t square. Correct, this will be real actually. Now j omega, you can divide the j omega, okay, this is like this. So if you divide the j omega, na, this will actually be, the first term will become real, j omega cancel, minus t upon 1 plus omega square t square. And then the next term will be 1 by j omega. Dear, what is 1 by j? Let me write 1 by j as minus j. Then what is left in the denominator? Omega 1 plus omega square t square. Clear? Okay, right. Good morning, Nanendra. Good morning, Bhanu. Now see here, this is what is known as the Cartesian form of the complex number x plus jy format, where what is the value of x, dear? The value of x is minus t upon 1 plus omega square t square. The value of y is given by minus of j. Okay, yeah, let me write this with this was plus minus. I have already written there. Okay. So, the imaginary part is minus j by omega 1 plus omega square t square, correct? Okay. Now, sometimes, you know, in fact, there have been questions in GATE, simple 1 mark, tell the quadrant in which the polar plot will lie. Okay, tell the quadrant in which the polar plot can lie. Okay, see here, x is always negative, minus sign is there, na? T is the time constant, which is of course by default positive, right? Then what about y? Okay, sorry, j I should not write here. I'll write only the imaginary part y. So this is minus 1 by omega, 1 plus omega square t square. And I told you polar plot is the plot for positive frequency. So since omega is positive, there is still a minus. So that means overall y is also negative. So can you tell me in the which quadrant plot should come? When I'm going to plot gj omega, hj omega, it has real and imaginary part both negative, and real and imaginary part both negative represents third quadrant. Represents what? Represents the third quadrant. So the plot will be in third quadrant. Okay, that also they can ask. There has been question in 1 mark in GATE. Okay, just tell the quadrant of the polar plot. Okay, just tell the quadrant of the polar plot. Which part you want, Burand? Okay, Praneeth. Okay, so third quadrant. Okay, now our intent is to plot. Let's complete the plot as well. One more thing before I start plotting, I want to show you every crystal clear calculation in the first one, and then I will give you some shortcuts also. Now, second, what is gj omega at j omega? Gj omega at j omega is actually 1 upon j omega 1 plus j omega t, and let me as, okay, some magnitude e power j phi. Okay, r e power j theta format. So what is going to be the magnitude of this? What do I mean by magnitude? I mean mod gj omega at j omega. Mod gj omega at j omega. Okay, that is going to be magnitude, means omega. Okay, 1 is 1, j omega magnitude omega, and for the complex number you will write 1 plus omega square t square under root x square plus y square. Okay, what about the phase? By phase I means angle gj omega at j omega. Angle gj omega at j omega, and that will be how much? Numerator is positive real number 0. For denominator, we'll subtract the phase. J omega pure imaginary. For pure imaginary number, how much is the phase? 90 degree. Then for x plus jy, tan inverse y by x. So tan inverse omega t by 1, which is tan inverse omega t. That's it. Okay, this is the magnitude and phase of the complex number. Okay, now I will tell you, usually 2 to 3 frequencies are enough to draw the polar plot. Okay, what are 2 to 3 frequencies? Okay, I'll write down here. What are the data I have got? I have got the data. I have got two data. In Cartesian form, it is minus t upon 1 plus omega square t square. And I'll just write down that calculation. Minus 1 by omega 1 plus omega square t square. Then in the Euler form, the magnitude obtained is 1 by omega under root 1 plus omega square t square. And then the phase obtained is minus 90 minus tan inverse omega t. Okay, now let me write down the calculation for omega equal to 0 plus. Now, of course, as I told you, this is a plot for positive frequency. 0 plus is trying to simply indicate that, okay, we are trying for positive frequency, 0 or little greater than 0. Okay, omega equal to 0 plus. What is the phase? Let me start with what is the x value? Minus t. What is the y value? Omega is 0, minus 1 by infinity, minus 1 by 0, minus infinity. Okay, good morning, Mahesh, right? Now see, what about the magnitude? Magnitude 1 upon 0, infinity. What about the phase? Minus 90 minus tan inverse 0. Tan inverse 0 will be 0. So phase will be minus 90. Okay, phase will be minus 90. Now next thing is, if I talk about omega equal to infinity plus. For omega equal to infinity plus, what is the value of x? Now see, omega is in denominator. 1 upon infinity, 0. X will be 0. What about y? Again 1 upon infinity, 0. Okay, what about magnitude? 1 upon infinity, 0. What about the phase? Minus 90 minus tan inverse infinity. Dear, what is tan inverse infinity? Is 90 only. So this will be minus 180 degree. Okay, now let me also tell you what is the meaning of minus 180 degree. Minus 180 degree means which axis? Minus 180 degree means which axis? On which axis the phase is minus 180 degree? Negative real axis, na? Okay, and on which axis the phase is minus 90 degree? See, always. Okay, first I told you minus 180 degree. Okay, so minus means clockwise. Clockwise 180 degree. Okay, so I come to negative real axis. Then I am telling you minus 90. What is minus 90? Minus means clockwise. Okay, and 90 means you come to y-axis because angle is always measured with the positive real axis. Okay, so minus 90 means negative y-axis. Okay, negative imaginary axis or negative y-axis. Everybody okay? Okay, everybody okay? See, for every question, all these detail will not be required. Just for the first or second question. Okay, then we'll come to shortcuts. Okay, now I want to plot this. Okay, so now have a look into it. Tell me dear, when omega is infinity, infinity plus again means positive side indication. When omega is infinity, what is the x and y coordinate? 0, 0. What is the meaning of 0, 0? Okay, which point is 0, 0? Origin, na? Or you can say this also, magnitude is 0 means origin, because magnitude is distance of the complex number from origin. So if distance is 0 means you are at origin. So magnitude will be 0. Okay, so omega equal to infinity means this particular point. Okay, this particular point. Okay, then, okay, then what is the phase? Minus 180 degree. That means you will come to the origin. You will come to the origin, but along negative real axis. Along negative real axis. See, you can touch the origin in many ways, na? Like this, like this, like this, like this, but you have to touch along negative real axis. What is the negative real axis? This is the negative real axis. That means you have to touch the origin. Okay, so that you come tangential to the negative x-axis. But still there are two cases, whether you are coming from second quadrant, whether you are coming from third quadrant. Okay, so look into the starting, omega equal to 0. What is the omega equal to 0? X and y both negative. X is minus t, y is minus infinity. Or one more thing I told you. I already told you the plot has to be in third quadrant. So you will be coming from third quadrant direction. Okay, or you can see here also. What is x minus t? Y minus infinity. Where is this point? Y minus infinity means deep down. Okay, here. Okay, so that means this case has to be taken. So let me draw it now. That coming, okay, from minus infinity height, y minus infinity, vertical minus infinity, I should be coming so that I come tangential, okay, to the negative real axis, and then I dive into the origin. This frequency was infinity plus and this is 0 plus. Okay, this is 0 plus, this is infinity plus. Okay, entire plot has to be in third quadrant. That is why I don't go to the other quadrant and come like this. Okay, now I will tell you one more point. In some of the books, for this particular function, how the plot you will see, now I will tell you very clearly. In some of the books, you will see the plot given like this, which is not going to affect the stability answer, honestly, but this is not the correct one. This is incorrect one. This is incorrect if you see this in the books. Okay, why? Because at omega 0, okay, you are not starting exactly from y-axis, because if you start from y-axis, x will be 0. But you see, what is our x value? Our x value is minus t. That means there has to be some gap. And also, when omega will increase, the magnitude of x has to decrease continuously. Okay, magnitude of x, that means this distance is decreasing and then coming to the origin. Hope you have got it. Okay, right? Hope you have got this point. Okay, in fact, sometimes they may ask you the concept of asymptote as well. Know each and everything. Know each and everything here. Okay. I can say that this polar plot, if you go towards infinity, this polar plot will be touching this line. What is this line? This line is parallel to y-axis given by x equal to minus t, because when you go towards infinity, the x coordinate is actually minus t. Okay, so this line is also known as asymptote to this particular polar plot. This is also known as asymptote to this particular polar plot. Okay. Asymptote to this particular polar plot. Okay. No, Ritvik, clearly 0, 0 is for omega infinity. You see here, right? This is the asymptote for the polar plot. And anywhere you see this, this is the wrong polar plot for the given question. Okay. Be very clear. Okay. Be very clear. Okay. Right. Okay. This is how I have drawn. Now my point is, are always two frequencies 0 and infinity enough to draw the polar plot? Let me tell you, mostly yes. If your question is a MCQ option based question. Sometimes if you want to go into details of stability, where another important frequency, which I call it as critical frequency, where the polar plot changes the quadrant. Here polar plot does not change the quadrant. It is entirely in the third quadrant. But there will be polar plots in combination of different quadrants. So when you go from one quadrant to other quadrant, you change quadrant. And to change quadrant, you cut the axis. Either x-axis or y-axis, and whenever you cut any axis, that frequency will be important for us, known as critical frequency. Okay, in special cases also known as phase crossover frequency. Okay, so we'll come to that, but okay, right now this particular plot is done. Okay, any doubt here, you can let me know. This has to be the correct answer. Again, I repeat, that is not the correct shape. Okay, that is not the correct shape. Okay, now I will also introduce the concept of critical frequency, but before that, now let me simply tell you, okay, if I wanted to only draw the polar plot quickly, what will be the shortcut you will apply? So see, normally some GSHS will be given to you, open loop transfer function. Suppose k 1 plus st1, 1 plus s2, some zeros are given, some simple zeros are there, divided by s power n, poles at origin, 1 plus sta, 1 plus stb, etc. Okay, some pole terms are there, right? Then what is n here? S power n, n is the poles at origin. Then what is P? Total number of poles. Total number of pole means including origin and the other, everything. And suppose Z is the total number of zeros. Total number of zeros of open loop transfer function. Okay, so these are the basic details. Then for most of the cases, okay, a shortcut, you only need a starting angle. Okay, that is for omega 0, and a diving angle. Now what do I mean by diving? Diving means, dear, what you observed. Okay, if omega is infinity, what you observed, what happened? If omega is infinity, what you observed, what is the magnitude? 0. And 0 magnitude is at origin. That means you are at origin. Okay, so diving means dive into origin. At what angle you dive into origin? You can call it as ending angle also, but I call it as diving angle, dive into origin. There are one or two exceptions to this formula. I will tell you everything crystal clear. Okay, the starting angle is given by minus 90 degree into n, where n is the number of poles at origin. Okay. Diving angle is given by minus 90 degree into p minus z. Okay. Otherwise, every time whatever expression given, you will convert to the frequency domain. Then you will calculate the phase separately. I am giving you the phase value directly. Okay. These are the phase values that will turn up. Okay. Now, if n equal to 0, see, if n equal to 0, okay, what will happen if n is 0? Starting angle will become 0, no? Okay, for n equal to 0, the theta st will become 0 degree. And what is 0 degree? Positive real axis only, because angle is measured with positive x-axis. 0 degree means you are at positive x-axis only. Okay, so the theta st 0 means you are on the positive real axis. Okay, and polar plot also starts with finite magnitude. Why? Because what is the meaning of n equal to 0? Something like this. Okay, you may have some function like this, s plus 1 upon s plus 2, s plus 3. No poles at origin, no s power n turn. Okay, so dear, if there is no s power n turn, generally also if I show you, if I remove this and then you put s equal to 0, what do you get? If you put s equal to 0, all these terms will become 1. Okay, so what will be the answer? K into 1 divided by 1, answer will be k. That means some finite point on the positive real axis. Some finite point on the positive real axis. That is what? Okay, so whenever n is 0, there are no poles at origins, then the polar plot will always start with finite magnitude. We will take the question also in this case. You just have to wait for a little bit time, and the polar plot starting from positive real axis. But for n not equal to 0, the plot, now see, if n not equal to 0 means poles at origin. So poles at origin means whenever you put, I'm talking about starting means s equal to j omega, omega 0. So s equal to 0. So if you put s 0 in the denominator 0, 1 upon 0, infinity. 1 upon 0, infinity. So always the magnitude will be infinity. So if n not equal to 0, polar plot starts with infinite magnitude with the starting angle based on number of poles. That is what happened in our previous case. In our previous case, you see the value of n. There is one pole at origin. So polar plot started where? See where is polar plot starting? From some infinity. This is the starting, 0 plus. It is starting from infinity. Okay, infinity. Okay, this is what you should know. This is what you should know. Okay, now I will add exception to it, but just you have to wait here. I will add exception also. Okay, but yeah, let me go back to the previous example. What was the previous question? The previous question that was given to you, if you are only interested in a quick sketch, 1 upon s, 1 plus st, no need to convert to frequency domain, no need to calculate any phase or magnitude, just write down the starting and diving angle. Starting angle minus 90 degree into n. What is the n? Number of poles at origin, which is 1. Okay, the starting angle is minus 90 degrees. Minus 90 means which axis? You should only know minus 90 means which axis? Negative real axis. Sorry, negative y-axis. Minus 90 means negative y-axis. Diving angle. Diving angle is given by the formula minus 90 degree into p minus z. That is minus 90 degree into p. P means total poles. 1 at origin, 1 on minus 1 by t. So total poles are 2 and total zeros are nil. Okay, so it is minus 180 degree. What is minus 180 degree? Minus 180 degree means negative x-axis. Negative x-axis. Negative x-axis. That is what is theta d. Correct? Okay, so the theta d means, I told you what? Theta d means diving. So dive, when you dive into origin, you should be along negative x-axis. Okay, negative x-axis. This way or this way. Okay, but which of them? Okay, see the starting. Where is the plot starting from? Negative y-axis. So you have to start from down to take this case. Okay, so start from down and just come and dive into the origin. Just dive into the origin. Okay, such that you are parallel or tangential to the negative real axis. Okay, this is starting 0 plus, this is diving means infinity plus. This way you should quickly draw. Okay, but this is a shortcut to draw. This will have the missing details. I mean, if they ask you what is the asymptote, that cannot I say, because asymptote means proper coordinates were required. That I have done earlier. But in many cases, if you are only interested in shape and matching the option, you can directly use it. You can directly use it. Okay. Yes, Mohammed Abrar, you can say starting angle depends on type, but be careful. Type depends, type is defined only for unity feedback. I have generally considered GSHS. Type of the system is defined as the number of poles at origin if the system is in unity feedback. Okay. That's why I didn't use the word type here carefully. Okay. Okay, everybody. Now, okay, now this rough shape is obtained clearly and we will do it at many places. Okay, only by starting and diving angle. Only by starting and diving angle. Okay, but now there are some exceptions to this. Exception means slight changes. If there are poles and zeros in the RHP, okay, then diving angle will not change dear. No change in the diving angle, but starting angle will change. How the starting angle will change? If there is a pole in RHP, starting angle will become minus 90 degree into n minus 180 degree. Starting angle will be minus 90 degree into n minus 180 degree. Okay, that means the same formula reduced by minus 180. If there is a 0 in the RHP, same formula plus 180 degree. Same formula plus 180 degree. Correct? Same formula plus 180 degree done. Minus 90 degree into n plus 180 degree. Okay. So we'll see if there are pole or zeros at origin, we'll slightly change the starting angle. No change in the diving angle. Then if p less than equal to z, okay, don't use the tricks as there is no diving into origin. Yes, the diving into origin will only come, as I told you, have a look into this. If p less than, that means more zeros as compared to pole, s plus 1, s plus 2 divided by s plus 3. So now when you put s tending to infinity, the magnitude will be infinity. Okay, that means not origin. Normally what is happening for s infinity, you are diving into origin, but this will not dive into origin. Okay, so we'll again go by the basic approach as I mentioned. Okay, that means z has to be less than p. Okay, degree of numerator less than degree of denominator. Okay, that means consider the function as a strictly proper function. What is a strictly proper function? The degree of numerator, okay, the degree of numerator is less than the degree of denominator. That means total zeros less than the total poles, not even equal. Okay, that is one thing you have to be careful here. Okay, otherwise, you can expand into the magnitude and phase form or Cartesian XY form, and still you can solve it. Okay. Now see, one more important frequency will be required here. Okay, let's add that important frequency by taking this next and a very crucial question. In GATE or in many competitive exam, directly, indirectly, you will find lots of question on this type of transfer function. K upon S, 1 plus ST1, 1 plus ST2, type 1, okay, and third order. Very important. See, there are some techniques of drawing the polar plot by type and order, okay, but again, I don't want to go into that, only starting and diving. Let's fix one approach. Okay, let us fix one approach. Okay, this is known as type 1. Again, if I consider unity feedback, type is only defined for unity feedback. This is type 1 order 3 transfer function. Okay, because when you form the characteristic equation corresponding to this system, it will be cubic. Okay, now see here, if I only want starting and diving, see, what is the theta st for this question? Minus 90 degree into n. N is 1. N is 1. That is minus 90 degree. Okay, what is the diving angle for this? Minus 90 degree multiplied by p minus z. That means minus 90 degree into total number of poles, which is 3, and there are no zeros yet. We'll come to zeros case as well. Minus 270. Now minus 90 means negative y-axis. And what is minus 270? You think, na? Minus means clockwise. So 90, 90, 90, 270. Where do you reach? You reach positive y-axis actually. Okay, so you will reach positive y-axis. You will be reaching the positive y-axis, correct? You will be reaching positive y-axis. Done, everybody? Positive y-axis, right? So, if I want to approximately draw this curve, without any much effort, if I want approximate shape, see, diving, start with diving. Dive means dive into origin. Okay, but along positive y-axis, dive into origin along positive y-axis. Okay, but you have to start where? Okay, you have to dive along positive y-axis. Understood? This is positive y-axis, but you have to start where? You have to start from negative y-axis. Now, a very simple logic. You have to start from negative y-axis and you have to go towards positive y-axis. So you will change quadrant. Na? You will have to change quadrant because your starting is along negative y-axis. Your diving is here. Your diving is here. Right? So that means this time the polar plot will change the quadrant. And it will approximately be of this kind. It will approximately be of this kind. Okay. This will be infinity plus, this will be starting 0 plus. Okay. So in this case, you will change the quadrant from third quadrant to second quadrant. Okay. So there is a frequency in between where the polar plot is changing the quadrant. Okay. Where polar plot is changing the quadrant. Now, if I have to actually do stability analysis, I will require this frequency. I will require this frequency, the coordinate of this point, everything will be required. Clear, everybody? Okay. So this is critical frequency omega c. This is going to be a critical frequency point omega c. I'll tell you what is this critical frequency and how do you calculate. Critical frequency omega c. It is the frequency at which it is the frequency at which polar plot changes quadrant. Okay, that is, to change the quadrant, it is intersecting some axis like negative x-axis. Okay, so that means I can say polar plot intersects any coordinate axis. Okay, now you might have also listened about the phase crossover frequency. See, critical frequency can be anywhere. Understand the difference. Critical frequency can be here also, here also, here also, here also. All this is critical frequency. Okay, whenever polar plot cuts any coordinate axis, this is known as critical frequency. But when the polar plot specially cuts the negative real axis, okay, when the polar plot cuts the negative real axis, that is also known as omega p. What is omega p? This is important for gain margin actually. Phase crossover frequency. This is known as phase crossover frequency, correct? Phase crossover frequency. This will be known as phase crossover frequency. Clear, everybody? This is important for gain margin. Okay, this is actually required for gain margin. So if required, we will discuss the gain margin and phase margin in a separate session. Today, completely on Nyquist plot and polar plot and the stability criteria. Okay, so when you cut any coordinate axis, it is the omega c, but when you specially cut negative real axis, okay, when you specially cut negative real axis, that frequency is known as phase crossover frequency. Okay, like here, I am cutting negative real axis, so this omega c can also be known as omega p. Now, how do I calculate this? Because in the beginning, I don't know which axis it might be cutting. Suppose I only look into the function. How do I calculate this omega c here? Have a look into this function and let me convert this to the frequency domain. Now, coming to the detailed calculation, gj omega hj omega. Coming to the detailed calculation, gj omega hj omega, which is k divided by j omega 1 plus j omega t1 1 plus j omega t2. Okay, this is what is gj omega hj omega given. Okay, what is the magnitude function here? Okay, what is the magnitude function here? The magnitude function, that means mod gj omega hj omega will be numerator k divided by j omega magnitude omega and then root over x square plus y square calculation. Root over 1 plus omega 1 omega square t1 square 1 plus omega square t2 square. Okay, then the phase, that is angle gj omega hj omega. Okay, what is the value of this phase? The value of this phase will be numerator positive real number 0, denominator 90 degree, denominator means minus phase, then again tan inverse y by x, that is tan inverse omega t1, and next is tan inverse of omega t2. This is the value of phase. Now, let me simplify this tan inverse a plus tan inverse b. When I simplify, I will be getting tan inverse of a plus b, that is omega t1 plus omega t2 divided by 1 minus ab, 1 minus omega squared t1 t2. Okay, tan inverse omega t1 plus omega t2 upon 1 minus omega squared t1 t2. Okay, tan inverse a plus b upon 1 minus ab. Now, what is that critical frequency? For critical frequency, try both numerator and denominator of the, final answer. Simplify everything in terms of a single tan inverse term and then take the numerator and denominator equal to 0. Okay, if you take numerator equal to 0, okay, you get omega 0. Numerator 0 means omega 0, but omega equal to 0 cannot be the critical frequency because the critical frequency is between 0 to infinity. When you start and when you end, you are changing the quadrant in between. Okay, so this cannot be the critical frequency. Okay, denominator equal to 0. Now try the denominator equal to 0. If you try denominator equal to 0, that means 1 minus omega squared t1 t2 equal to 0. So you get the value of omega. That will be omega c. 1 upon t1 t2. 1 upon root t1 t2. Okay. What is the magnitude at this frequency? Okay. Right. So, dear, when you put down What frequency? When you put down omega c 1 upon root T1 T2, you will get this magnitude. On solving, I will write down the answer here, k T1 T2 upon T1 plus T2. That you can check yourself. Na? Okay, you will get the answer on solving, putting this frequency here, and solving you will get k T1 T2 upon T1 plus T2. Now the neat and clean, complete Nyquist or polar plot sketch for the given function, with the mentioning of critical frequency and all required points. Now see here. Okay, which function we are talking? We are talking about the important function k upon s 1 plus st1 multiplied by 1 plus st2. Okay, how will be the polar plot for this? The polar plot of this will be like this. The shape already we discussed, na? Okay, right, the shape already we discussed. Okay, so what is going to be the complete details now? This was the starting frequency 0 plus. This is the dive into origin at infinity plus. Okay, in between there was the critical frequency. Okay, this is known as the critical frequency. What is that critical frequency? I'll write down the details separately. This is the critical frequency 1 upon root T1 T2. Okay, or here the critical frequency is also equal to omega p, the phase crossover frequency. What is the magnitude? Magnitude means distance from origin. That means how much is this much of the magnitude? Okay, this was calculated as k T1 T2 upon T1 plus T2. One last point, I'm not calculating, but rather I'm giving you that answer. One last point, if you wanted to calculate the asymptote for this, like I told you the concept of asymptote for the previous example, near polar plot cuts which line? The polar plot intersects which line? This will be the line, okay, given by the formula x equal to minus of summation of both the time constant. Like previous one was minus t, this will be minus of T1 plus T2, and this is the asymptote to this particular polar plot. Okay. Correct, Harsh. Okay, Yogi, noted. Correct, Harsh. If you actually wanted to calculate only omega p, you can do that. Okay. But what my point is, suppose you are given this transfer function, open loop transfer function, and you don't know the polar plot, you don't know which axis it can cut. Okay, so that is why I'm telling, if you don't know which axis it can cut, you don't have any idea about the shape, so you can try numerator and denominator equal to 0. Okay, if there is any critical frequency, again I repeat, critical frequency means when you cut any coordinate axis, okay, then it will be only obtained by these two calculations, either numerator 0 or denominator 0. If you only want omega p, phase crossover frequency, then you can directly put to minus 180 degree also. Okay, that is also okay, right? Okay, that is what we actually do in the gain margin problem. Okay, na? Okay, this is what it is. Okay, right? Now see what will happen if you equate this to minus 180. Already 90 is there, so this should be 90. And how do you get 90? Tan inverse infinity. So to make this to infinity, denominator has to be 0. Correct? Chalo. Okay, so this is the complete polar plot shape for this. Okay, now what will I do, dear? I will take some more polar plot, but I want to stop here. See, we'll do some more polar plot. See, this is the case. This is the case when there are no poles at origin. I told you n equal to 0 special condition. Okay, then this is a 0 in RHP. We'll come to this, but I want to go to this question right now. First, where is that gone? Here. First, I want to go to this question right now. Okay, where I want to complete the Nyquist plot. Okay. Yeah, asymptote will be multiplied by k rather, shadow, correct. Asymptote point will be x equal to minus of this, minus k. I've taken k, na? Okay, so that any automatically will come up here also, k times this. Okay, it will be k times this automatically. Okay, yes, shadow, correct. Yeah, so see why I'm directly jumping to the Nyquist plot. See what type of function I have taken, k upon s, s plus 1, s plus 2, type 1 order 3. Type 1 order 3. Okay, you can, write down this function as how much? Okay, rather you can take the 2 common in the denominator, writing it in the time constant form. This is 1 plus s, and if I take 2 common, this is 1 plus s by 2. Okay, now let me shift the k to the numerator actually. K by 2 upon s, 1 plus s by 2. Okay. Now, rather I want to do the complete Nyquist plot and then the stability analysis, range of K for the closed loop stability. Range of K for the closed loop stability, right? What you want to calculate by RH, Bhanu? Which point? Okay. So now see here, how do I complete the Nyquist plot of this one? How do I complete the Nyquist plot? I'll generally tell you the steps. Okay, for Nyquist plot, okay, the first thing is always polar plot. And if you are done with the polar plot, you are almost done. Okay, for Nyquist plot, the first step is getting the polar plot correct. And that is a major step that I think you have understood. Okay, now then draw the plot for negative frequency. As I told you, polar plot is the plot for positive frequency. To draw the plot for negative frequency, just take the mirror image of polar plot. Just simply take the mirror image of polar plot about the horizontal. That means about real axis. This is because of conjugate symmetry property of Fourier transform you study, right? Okay. Okay, so please take the mirror image of the polar plot about real axis. Okay, and then closing from -0 to +0. Okay, join the omega equal to 0 minus to omega equal to 0 plus. Okay. Or I'll write down the value of the angle finally. Join omega equal to 0 minus to omega equal to 0 plus through an arc of infinite radius and angle minus n pi. Minus n pi means n pi in the clockwise sense. Okay, negative angle you know is clockwise. Okay, where what is n? N is same, the number of poles at origin. The number of poles of GSHS at origin. Okay, this rotating through clockwise angle is of course assuming that the Nyquist contour is also clockwise. Assuming clockwise Nyquist contour. Okay. Now you come up here. Let me explain you these steps actually with the help of this one. So why I'm starting with this one? Because for this function, I already know the polar plot. I just want to complete to the Nyquist plot. Okay. K, some constant upon S, 1 plus ST1, 1 plus ST2. Tell me what is going to be the omega C. Tell me what is going to be the cutoff frequency, that critical frequency or phase crossover frequency. Okay. Here omega P is equal to omega C. That is 1 upon root T1, T2. Okay. Gm of both the time constant here. So what is the value of T1? T1 is 1 and T2 is 1 by 2 time constants. Okay. So this becomes 1 upon 1 by root 2, that is net value root 2. At omega C, what is going to be the magnitude? At omega C, I told you magnitude is K. K here is K by 2 actually. K by 2 T1 T2 divided by T1 plus T2. Divided by T1 plus T2. So that is going to be K by 2 into T1 T2. T2 is again half divided by 1 plus half. Okay. So how much is the net answer? K by 2 into 1 by 2 divided by 3 by 2. Oh, okay. At least 1, 2 I can cancel. It will be K by 6. It will be the K by 6. Correct? It will be K by 6. Done. Okay. So the magnitude at the critical frequency. Okay, now let me come on sketching it. Sketching the entire Nyquist plot. Okay. What is the polar plot for this particular function? Already I told you, na? We just completed this particular function. This is what I need to draw here with the required details. Correct. So let me start with the polar plot for this function. This is the polar plot. Okay, this is the frequency infinity plus where you dive into origin. This is the starting frequency 0 plus. Okay, and then this is the critical frequency or phase crossover frequency here. But before I write down the details, let me complete. What is the second step I told you? Okay, take the mirror image about about the real axis, about horizontal. So take the image of it. Just simply take the image of it. Okay, so image of infinity plus will be infinity minus, 0 plus image will be 0 minus. Clear? This is the step number 2, one by one. And step number 3, join the 0 minus to 0 plus. Okay, through an angle of, okay, through an angle of, what I told you, okay, through an infinite arc, okay, with an angle of n pi in the clockwise sense. So what is the n for this question? What is the n for this question? See here, what is the n for this question? Number of poles at origin is 1. That means what about the closing angle? Step number 3 requires the closing angle. The closing angle will be pi clockwise. Okay, n pi, but n is 1. So pi in the clockwise sense. So 0 minus to 0 plus. Now it is understood. 0 minus is where? Positive y-axis. Top. 0 plus is negative y-axis. So from positive y, if you have to come to negative y, you will automatically rotate through 180 degree around, right? Okay, so that 180 degree is coming. In which direction? Clockwise direction. From here, I will start and I will take an arc of infinite radius in the clockwise direction. See dear, again how this closing is coming. I am telling you now, I have not derived the Nyquist plot or Nyquist stability criteria. Okay, Nyquist plot or Nyquist stability criteria I have not derived and not required at the end moment also. But if you still want the complete derivation of Nyquist stability criteria, that also is available on the OM YouTube channel. You can watch it. Okay, in that particular video, rather I have not taken much questions, but rather I have focused on the entire concept, what this Nyquist is and how it is derived actually. How it is derived actually. Okay, so this is how it is. Okay, now if you see here, okay, infinity minus, I'll draw the arrows, infinity minus, okay, to 0 minus, then 0 minus, I'm going towards 0 plus. From 0 plus, I will go towards infinity plus. That's it. Okay, now let me write down the other details. What was this? This was omega c. Okay, equal to how much? Root 2 was calculated. What is the magnitude here? The magnitude at this frequency was calculated as k by 6. K by 6. Okay, the magnitude here was written as k by 6. Clear everybody? See, definitely you can calculate. See, point is, if I give you just GSHS and ask you the range of K for closed loop stability, yes, you can use Routh-Hurwitz. Actually, you should use Routh-Hurwitz only. But understand the point here. What is the intent of this question in today's session? I will next come to some questions very common in GATE where I will not give you this GSHS. I will give you some hidden, some partial information about GSHS and I will give you this Nyquist plot. I will ask you look into the Nyquist plot and then tell the range of K for stability. Then what I am trying to explain you is important. Then you can't use Routh-Hurwitz. Okay, na? That is what. Otherwise, what is the Routh-Hurwitz makes it a very simple question. Okay, got it? Now, range of K for closed loop stability. So I just now told you 3 simple steps to draw the Nyquist plot. Polar plot. Okay, then plot for negative frequency. Just have to take the mirror image. The reason behind this is conjugate symmetry. Okay, Fourier transforms, those who know, you know the very, very important property of conjugate symmetry. Okay, and 0 minus to 0 plus I explained you. Okay, now stability. Now see, from the Nyquist plot, okay, there are 2 things. Okay, there are 2 things. If you notice the encirclements of origin, number of encirclements of origin means 0, 0. Okay, it is given by the formula P minus Z. Again, as I told you, I have assumed clockwise Nyquist contour. If it is by chance, anti-clockwise Nyquist contour. Okay, the details of which will usually be mentioned in the GATE PYQ. Then you have to use Z plus minus P plus. Now see, in the beginning of the video, I told you what is P and Z. What is P and Z? Total number of poles and zeros of GSHS. What is P plus and Z plus? P plus and Z plus. Plus means positive side. Positive means right hand side. Okay, so I just use this notation plus to make you remember that we are talking about right side poles and zeros. So see, what is P plus? Poles of GSHS in the RHP. Z plus, poles of GSHS, okay, Z plus, zeros of GSHS in the RHP. N, number of encirclements of the origin. Okay, number of encirclements of the origin. But actually, for stability, we don't want the zeros of GSHS, but for stability, we want the zeros of. Okay, if you actually want stability, so we are interested in Okay, see, for stability, I'll write down a simple remark. You all know that stability depends on the poles of the closed loop transfer function. Poles of the closed loop transfer function are equal to roots of characteristic equation. Roots of characteristic equation. What is the characteristic equation? 1 plus GSHS equal to 0. That means I am not interested in zeros of GSHS. I am interested in zeros of 1 plus GSHS. Okay, I am interested in zeros of 1 plus GSHS. Okay, so what we actually do is, rather there are two things. We think about 1 plus GSHS plot, or we think about GSHS plot only. Okay, but we shift the origin. Okay, we shift the origin. Okay, so number of encirclements of the modified origin is then considered. Okay, modified origin. Okay, what origin? So when you make this equal to 0, you get GSHS equal to -1. Actually, I want the encirclement of -1. Okay, so I want the encirclement of modified origin, sometimes also known as critical point of the Nyquist plot. Critical point of the Nyquist plot. Okay, so I want the encirclements of this origin -1, 0 by the GSHS plot, by the Nyquist plot. Okay, then P plus is again known as the poles of GSHS in RHP, but Z plus is known as the zeros of 1 plus GSHS. Zeros of 1 plus GSHS, that means roots of characteristic equation, and that is what is required for stability. And what do you want? How many poles or how many roots of characteristic equation in RHP? For stability, the Z plus should be 0. There should be no root of characteristic equation in the RHP. Correct, na? There should be no root of characteristic equation in the RHP. Right? Right. This is what it is. Stability of the closed loop system with Nyquist plot can be analyzed. Okay. Right, but I have given you the other slide also, because sometimes just a mathematical question they can frame where they only are interested in the encirclements of the actual origin, or where they are interested in the zeros of GSHS. Okay, let me tell you let me summarize one thing here. Okay, in either case, P plus is the number of poles of GSHS, open loop transfer function in RHP. That is there in either case. Okay, but if you want Z plus as number of zeros of GSHS, zeros of open loop transfer function in RHP, which has nothing to do with the stability of closed loop system. Okay, but then if you want the zeros, mathematically they can frame this question. So what is N? N is the encirclements of zero, zero. And remember, this N also comes with a sign convention. Okay, this N is positive for anti-clockwise encirclement. So automatically negative for clockwise encirclement. Okay, then if you actually want to talk about stability, so you want the zeros of characteristic equation, zeros of 1 plus GSHS lying in the RHP, then what is the value of N you have to use? Then use the value of N as the number of encirclements of the critical point or modified origin, that is -1, 0. Number of encirclements of the point -1, 0, right? Use the number of encirclements of the point -1, 0, correct? Okay, so yeah, coming back to the previous question, I want the range of K for closed loop stability. Okay, now where is -1, 0? -1, 0 definitely is on negative x-axis, -1, 0. But where? Do I know the value of K? No. Suppose K is 1. 1 by 6. 1 by 6 is less than 1. So -1, 0 outside. Or suppose K is 10. K is 10. 10 by 6. 10 by 6 is greater than 1. So -1, 0 can come inside also. So there may be two possibilities there. Okay, what I will now do is, there can be two possibility. Okay, first possibility -1, 0 outside, and second possibility -1, 0 inside. Okay, -1, 0 inside. What is the first possibility? -1, 0 outside the entire plot. If it is outside, it is not encircled. N will be 0. It will not be encircled. Okay. Second, if -1, 0 is inside, okay, so what will be the number of encirclement? Now you see, if this is inside, na, how much it is encircled by the Nyquist plot. To see here, everybody just follow with me. You just try to trace this with me. There is one encirclement like this. There is one encirclement like this. Okay, which direction I moved? Clockwise. There is one more outer encirclement. You look into this. There is one more encirclement like this. How many encirclements? 2 times. But both are in clockwise direction. Okay, both are in the clockwise direction. Clear, everybody? Okay, so n is equal to 2 times. Okay, but both the times in clockwise. Okay, that means n should be taken as -2. N is -2 actually in the second case. N is -2. Okay, once by the inner loop, once by the outer loop, as I have shown to you. Okay, so if I come to the stability formula, what is the stability formula? P plus minus Z plus. Okay, what is the P plus for the question? GSHS is given now. For the GSHS, what are the overall poles? S equal to 0, -1 and -2. These are the 3 poles now. Tell me how many poles in the RHP. P plus is what? Poles of GSHS in RHP. Nothing. There is no pole in RHP. Okay, 1 at origin, 2 in the LHP. There is no pole of GSHS which is strictly in the RHP. So P plus is 0. So n equal to P plus minus Z plus, but P plus is 0. Okay, so 0 minus Z plus. Okay, so what is Z plus? Z plus is minus n. Okay. What do you want for stability? Okay, for stability, Z plus should be 0. Now, if you want Z plus 0, that means n has to be 0. And n has to be 0 means case number 1. N has to be 0 means case number 1. Case number 2 should not come. Now, what is the case number 1? -1, 0 outside. -1, 0 outside means look into this distance. This is 1 in distance. This is k by 6. So, k by 6 has to be less than 1. Okay, so case number 1 will be possible if k by 6 is less than 1. Okay, case number 1 will be possible if k by 6 less than 1. So, what is the range of k? K less than 6. Okay, so for stability, what is the range? Of course, by default, k positive only. Okay, so for stability, the proper range of k is k between 0 to 6. By RH also you will get the same answer. Okay, but this is using the Nyquist criteria because as I told you, the actual question on Nyquist when it comes, they will not give you the complete GSHS. They will give you some partial information. Okay, but rather they will give you the plot. So you have to do the Nyquist plot analysis, apply the formula n equal to P minus Z or Z minus P, depends on the Nyquist contour. I have taken clockwise Nyquist contour here. Okay, everybody? Okay. That will be, Ritvik, that will be mentioned in the question, don't worry. Otherwise, all phase calculation and all will change. Na? Negative sign means everything will be changed by 180 degree. Our entire polar plot and everything will change. Correct? Correct. So, this is what is the complete Nyquist plot for this question with the stability analysis done, and the range of k for stability is 0 to 6. Okay, 0 to 6. Okay, fine. Chalo. Now, moving ahead. Yeah, coming back to a polar plot question. Come up here. Coming back to polar plot, and then again I will take a complete Nyquist plot question also. Polar plot. So polar plot means just by shortcut. I just want the basic shape of polar plot by the shortcut. Okay, that means starting angle and diving angle. Starting angle and diving angle. What is now important point here is n is 0. Correct, na? There are no poles at origin, no s power n term. So because n is 0, the polar plot starts with how much magnitude? Finite magnitude. And where it starts? Positive real axis, because starting angle will be 0. Na? How much finite magnitude? See, if you put s equal to 0, starting means s equal to 0, you will get 1 by 1 into 2. Okay. Diving angle. Okay, let me write down the diving angle. What was the diving angle formula? Minus 90 degree into P minus Z. Minus 90 degree into total number of poles 2. Total number of zeros nil. Okay, so minus 180 degree. So diving is minus 180 degree. Minus 180 degree, you know, is negative x-axis. Is the negative real axis. Negative real axis. Okay. Now, if I want to draw the shape approximately, have a look into the shape. What I told you, polar plot will start on the positive real axis with the finite magnitude. That magnitude is 1 by 2. Okay, so on the positive x-axis, somewhere here. And diving means dive into origin. Okay, dive into origin with how much angle? Minus 180 degree. Minus 180 degree. Minus 180 degree means along negative real axis. That means when you come and dive here, okay, you have to touch the negative real axis. That means from here to here means you have to change the quadrant. Okay, just I'll draw the approximate plot, something of this kind. Okay, this will be starting 0 plus, this will be the diving, that is infinity plus. From 0 plus to infinity plus. Now tell me, dear, what is this frequency? I'm not asking you to calculate, just leave it. But what is this frequency? This is critical frequency. But critical frequency. But is this also omega p? This time it is not omega p. I told you na, when you cut any quadrant, any coordinate axis, it is a critical frequency. But when you cut negative real axis, that is the phase crossover frequency. So you can't call it as omega p. In the previous case, omega c or omega p is same. But here, this is only omega c. Here, this is only omega c. Okay. Any doubt? Why this shape? Why not any other shape? You let me know. If you only want to know only the quadrants, so again I'll tell you, if you write down the phase expression, what will be the phase expression? Minus tan inverse omega by 2. Negative phase. So even for small frequency, omega 0, the phase is 0. But even for any small frequency, the phase will be negative, and negative phase means clockwise. Okay, so for any small frequency also, the next point has to be taken clockwise. That is why we are going in the fourth quadrant. Why not this one? Because if I take such a shape, okay, that means I have taken the first point for which angle will become positive angle, clockwise angle. Got the logic? Got the logic? Okay, keep telling me any doubts. Next question. Polar plot for s minus 2 upon s square, s plus 1, s plus 2. Now, important point is, see, what is the value of n here? N is 2, not equal to 0. That means polar plot will start from where? Polar plot starts with infinite magnitude. I told you two conditions, finite magnitude or infinite magnitude. Okay, it will start with infinite magnitude. With how much starting angle? With the starting angle given by the formula minus 90 degree into n. Right or wrong? Wrong. Okay, there is a 0 in RHP. Whenever there is a pole of 0 in RHP, non-minimum phase basically. Whenever there is a pole of 0 in RHP, then what happens? Then the diving angle will not change, starting angle will change. Okay, starting angle will change by plus 180 degree. By plus 180 degree. Right, by plus 180 degree. So this is minus 90 degree into n. N is 2. Okay, and plus 180. So minus 180 plus 180, this is going to be the 0 degree. Clear, everybody? This will be 0 degree. Okay, this is the starting angle. Okay, and this will be 0 degree. Correct, everybody? This will represent 0 degree. Okay, now what is next? Yeah, the diving angle will not change. So let us use the diving angle formula. Minus 90 degree into P minus Z, that is minus 90 degree into total poles are 1, 2, 3, 4. Total 0, there is 1, 0. Okay, so this becomes minus 270 degree. Minus 270 degree means how much? Just a second here. Just a second. Complete this question. Okay guys, yeah, sorry, let's continue here. So what I was telling is the diving angle is how much? Minus 270 degree, and minus 270 is what? Finally, positive y-axis. And the starting angle was 0 degree. 0 degree means, okay, 0 degree means positive real axis again. Okay, positive real axis. Now, let's come to the polar plot shape. Okay, now see here. Where do I start from? The starting is positive real axis, but infinite magnitude, not from a finite point. But diving is positive y-axis. Diving has to be positive y-axis. Okay, here. Or the diving has to be here. Okay, the starting has to be here. Okay, now it turns out to be, see, I'll tell you one or two basic calculation also. See, if you wanted to, if you want to understand this exact shape, na, if I want to write down the angle expression, see, write down the angle expression for this. What should be the phase expression for this? Okay, it will be tan inverse omega upon minus 2, tan inverse y by x. Okay, then denominator s square 90 2 times 180 degree. Okay, then s plus 1 tan inverse omega by 1. Next will be 3 plus j omega. So tan inverse omega by 3. Okay, tan inverse omega upon minus 2, tan inverse y upon minus x. Okay, this is further written as 180 degree minus tan inverse y by x. 180 degree minus tan inverse omega by 2. So this 180 will also cancel. Okay, and you will have the actual phase expression as minus tan inverse omega by 2 minus tan inverse omega minus tan inverse omega by 3. Okay, this is what it is. Okay, so now if I want to see now you can again see at omega 0, the phase will be 0, 0, 0. That is why 0. Okay, at omega infinity, diving means omega infinity, na? So in 90, 90, 90, 270. That is why 270 is coming. Everything is okay. But what I want is why exactly this shape, you know, because later on some students will have the doubt why only this quadrant. I'll tell you a simple logic again. Okay, I'll tell you a simple logic again. If omega is omega 0 means 0, 0, 0. But if omega is slightly greater than 0, if omega is slightly greater than 0, okay, try 0.1. Don't calculate, but just think slightly greater than 0. Okay, so some basic phase will come, take minus outside. Okay, some small angle will come, but with minus direction. If I tell you, suppose minus 10 degree, minus 5 degree, where will be that point? Okay, if you want to draw a point minus 5 degree, the minus means clockwise angle. Okay, some small angle will come, okay, but clockwise. Okay, that is why omega, when just greater than 0, it should be fourth quadrant. It should be fourth quadrant, right? It has to be the fourth quadrant. That's what I'm trying to explain here. Okay, so something of this kind. Okay, now because it is starting from fourth quadrant, okay, now multiple critical frequency. Why multiple critical frequency? This is infinity plus, this is 0 plus. Okay, see, this is omega C1. Okay, this is omega C2. Omega C2 is also equal to omega P. Okay, why multiple? Because multiple tan inverse term are coming. Okay, you simplify. I don't want the calculation, but again, the idea is, okay, when 2 or more tan inverse term come, then only I told you critical frequency is coming. There are 3 tan inverse terms, so multiple critical frequency is arising here. You can calculate the exact critical frequency by again simplifying the entire expression, tan inverse A plus tan inverse B. Then again, plus one more tan inverse term. Solve and then put numerator denominator equal to 0. Simple thing I told you. Okay. Right now, okay, Harsh, I hope your doubt also should be clear with one basic phase calculation. This is the answer. Okay. Chalo. Anyways, next. What is there next? Okay. Yeah. So before I go to the next, let me again update you guys. Okay. So big update for all the aspirants planning to prepare for GATE 27 in the offline manner. okay, in the offline manner, in front of the faculties, in a competitive atmosphere, stating with hundreds of students and getting that, real competition sense throughout the year. So the first offline course for GATE 27 at Home Institute is going to start, okay, is going to start on 26th of February. That is going to start 26th of February 2026. Okay, 26th of February 2026. This will be at our Hyderabad center, offline course for EC and EE both. Right. So this was the entire Nyquist plot. Now I shall give you one more question on complete Nyquist plot. The stability criteria and all was discussed. Sketch the Nyquist plot for GSH equal to plus 3 upon SS minus 1 and comment on stability using the Nyquist plot. Comment on stability using the Nyquist plot. Okay, come on, do this. Everybody, come on, try this one. Remember, first think about polar plot. Okay, first only think about polar plot. Then rest of the two steps are basically, I told you, formality. Let's only think about polar plot. Okay, let's only think about polar plot. See, what is the value of n? What is the value of n? N equal to 1, 1 pole at origin. N is not equal to 0. That means polar plot will start with how much magnitude? With infinite magnitude. For n not equal to 0, starting with infinite magnitude. With how much angle? Minus 90 degree into n? No. This time, like previous question, 0 in RHP, there is a pole in RHP. Okay, so if there is a pole in RHP, starting angle will be reduced by 180 degree. Will be reduced by 180 degree. Okay, will be reduced by 180 degree. Okay, so how much will be the starting angle? And then diving angle, no change. Diving angle will be minus 90 degree into P minus Z. That will remain to be same. Write down both the values. Okay, just write down both the values. Come on, everybody, do this. Okay, yeah, okay. So writing down the values, how much is the n value here? N value is 1. So minus 90 degree into 1, minus 180. The starting will be minus 270, which means positive y-axis. Okay, diving minus 90 degree into total poles 2, and there is a 0 as well. So the diving is minus 90 degree, meaning negative y-axis. Okay, if I only wanted the shape of the polar plot now, see, if I only wanted the quick sketch of the polar plot, what will I do? I will only use the starting and diving. Diving is negative y-axis. Okay, and starting is positive y-axis. Starting positive y-axis means top, and diving negative y-axis. Diving means dive into origin like this, and starting from here. Starting means 0 plus, diving means infinity plus. Okay. So as you are able to see, again there will be a quadrant change. So if you just wanted a quick polar plot, this should be the shape. This should be the shape, right? Okay, this should be the shape. But yeah, definitely for complete stability analysis also, I will require this point so that I come to know minus 1 comma 0 is inside or outside. That all will be required here. Okay, so let me complete this, and what is this? This is here omega c or equal to omega p. Okay, so omega c here is omega p. So what is the phase expression? I will require that phase expression now. Okay, what is gj omega h j omega? Gj omega h j omega is given by 10, okay, into s plus 3, or let me write it as 3 plus s, 3 plus j omega upon s, and minus 1 plus j omega, minus 1 plus s. Okay. Okay, firstly, what is the magnitude here? Okay, magnitude mod gj omega h j omega. The magnitude will be 10 and under root of 9 plus omega square divided by omega under root of 1 plus omega square. What is the phase here? Phase angle gj omega hj omega. How much is the angle here? Okay, minus of, starting with the numerator, tan inverse of y by x, tan inverse omega by 3, denominator minus pure imaginary 90 degree. Then again, sorry guys, again tan inverse omega upon minus 1. Tan inverse omega upon minus 1. This is what it is. Okay. So how much this phase will be equal to? This is going to be tan inverse of omega by 3. Okay. Minus of 90 degree. Okay. Minus of how much? Tan inverse y upon minus x. Okay. Tan inverse y upon minus x again. So 180 degree minus tan inverse y by x. 180 degree minus tan inverse omega by 1, correct? So when I finally simplify, this will be actually minus 90 minus 180 minus 270 degree and plus tan inverse omega by 3 plus tan inverse omega, tan inverse A plus tan inverse B. Directly I will do so, tan inverse A plus B upon 1 minus AB. Okay, so this will be minus 270 degree plus tan inverse multiplying by 3. So I get 4 omega upon 3 minus omega square. Okay, again, see, if you take numerator to 0, if you take the numerator to 0, omega will be 0, but critical frequency has to be between 0 and infinity. Okay, so I will take denominator equal to 0. Okay, that means 3 minus omega square equal to 0. So omega, see, the critical frequency is root 3 here. The critical frequency is root 3 here. Okay, at the critical frequency, how much is the magnitude? If I put the value of omega c equal to 3, omega c equal to root 3 actually. Omega c is root 3 here. So when I put the value of root 3, how much will I get? 10. 9 plus omega square will be 3 divided by omega is root 3 under root of 1 plus again omega square, that will be 3. So overall, if I correct the under roots, 12 and 3 into 4, that is 12. 12 cancel. So the magnitude will be 10. Magnitude will be 10. Okay. Right. Yeah, there's some doubts are coming. Yeah, let me just complete this calculation. I will look into the doubts. Okay. So now I will complete the polar plot for this one. Okay. That was simply the polar plot. I will now draw the complete polar plot with this omega p. Now see, omega c has been obtained by putting denominator 0. Denominator 0 means tan inverse infinity. Okay. Tan inverse infinity is 90 minus 270 plus 90. How much will be the phase? Minus 270, denominator 0, you get tan inverse infinity, and that is 90. And that is the reason the omega c corresponds to minus 180. That is the seen here also, na? Okay, which axis you are cutting? Negative x-axis. Phase crossover frequency. Phase crossover frequency. Now, have a look into this one. Let me draw the complete polar plot here. Nyquist plot rather. See this question carefully. Now see what is going to happen. Now see what is going to happen here is, let me start with the polar plot we have drawn. Okay, this was 0 plus. This is infinity plus, this was 0 plus. Okay, now what is the second step in the Nyquist plot? Take the mirror image of the polar plot. Take the mirror image of the polar plot about the x-axis. About the horizontal. Okay, so after the mirror image, 0 plus becomes 0 minus and infinity plus image is infinity minus. Step number 3, join 0 minus to 0 plus. So what is going to be the closing angle here? What is going to be the closing angle here? N equal to 1. Okay, n equal to 1. Remember, so if n is equal to 1, what will be the closing angle? Closing angle was n pi. Okay, so this becomes pi. Pi in the clockwise sense. Okay, closing means 0 minus to 0 plus. So 180 degree again in the clockwise. 180 in the clockwise. But remember, this is 0 minus. Okay, The joining, will it be this way? This is anti-clockwise actually. You have to go clockwise. 0 minus to 0 plus, you have to go clockwise actually through an arc of infinite radius. Okay, so this way joining has to come. Okay, from 0 minus to 0 plus through a clockwise angle. Okay, let me draw the complete arrow. This was infinity minus. From infinity minus, you go to 0 minus, 0 minus to 0 plus, 0 plus to infinity plus. Okay. This was the critical frequency, okay, which was evaluated to be √3. More importantly, what was the gain at this critical frequency? The gain at this frequency was, the magnitude at this frequency was 10. I mean, if this magnitude is 10, this is on negative real axis. So in the point form, if you want to write down it, this point will be minus 10, 0. So now automatically, where is minus 1, 0? This is minus 1, 0. This is minus 1, 0. How many times it is encircled? How it is encircled? How many times it is encircled? See here. Okay. It is encircled only once. It is encircled only by the inner loop. The outer loop, okay, is from minus 10 to minus infinity. It will not include the minus 1 point. Okay. So it is encircled one. How much direction? See, this is anti-clock. This is anti-clock. Okay. So minus 1, 0 is encircled only once. Okay. And that too in the anti-clockwise sense. In anti-clockwise sense, it is encircled by the inner loop or by the small loop. I will write down here for your reference. Okay, and one encirclement in anti-clockwise sense means n equal to plus 1. N equal to plus 1. Okay, now what is the stability formula? N equal to P plus minus Z plus. Okay, again assuming clockwise Nyquist contour. Okay, what is the n value? The number of encirclement is 1. What is P plus value? P plus is 1. Why P plus is 1? See here, na? P plus is the poles of GSHS in RHP. So it has a pole in RHP, which means P plus is 1. If GSHS has a pole in RHP, that means P plus is 1. Okay, so P plus is 1 minus Z plus. So what is the Z plus as per the Nyquist plot? Z plus is 0, indicating the system is stable. You can answer it using the Routh-Hurwitz or characteristic equation also, but I wanted the answer from Nyquist plot. From Nyquist plot. Okay, this is the correct answer. The system is stable. The system is stable. Right. Harsh, yes, it is possible. Polar plot can change quadrant multiple times. 2 times cutting the same axis is also possible. But if it is cutting, yeah, that also is possible. Quite possible. It may be consecutive also, in fact. Okay, there may be sometimes a plot of this kind, like this. Okay, cutting negative real axis 2 times. Quite possible. Okay, Harsh. Okay, next out, Bhanu, what do you say? How to say whether Nyquist plot? No. See, Bhanu, the formula n is P minus Z or Z minus P depends on Nyquist contour, not Nyquist plot. Nyquist path. Okay, and the details about Nyquist path will be either mentioned in the question or otherwise I'm taking by default as clockwise. Otherwise, some detail will be mentioned in the question, but that is Nyquist path. I hope you know the difference between Nyquist path and Nyquist plot. Nyquist path is the path in the S-plane for which the Nyquist plot has been drawn. Okay, that's why I'm telling you, if you want a complete derivation or discussion of the Nyquist of the derivation of Nyquist with the details, you can watch my video, Nyquist Stability Criteria, available on the OM YouTube channel. Rather, I will share you the link if required. At the end, I will share you the link of that video I am referring to, so that others can also revise the entire Nyquist Stability Criteria with derivation if you want. I'll share you at the end. Okay, let's continue right now. Okay. Okay, so again I repeat, this formula is as per clockwise Nyquist path, also known as Nyquist contour, not the Nyquist plot. Okay. Okay, dear. right? So this was the complete Nyquist plot for this given function, where polar plot also came, stability also came, Nyquist plot, multiple things. So see, I have brought some questions as conventional type also. Okay, it's the time for next question, number 7. Okay, now be very careful in this question, because what is the standard format? See, it's an option based question, but remember, the standard format of the function I have taken starts with the s being positive. You know, the s coefficient must be positive, because any negative sign is not simply a negative sign. It is a 180-degree phase shift, and all angles will change by 180-degree, right? So what will I do? Firstly, I will modify this function as, for that reason only I have brought this question, from the denominator 20s minus 1, take first of all minus outside. Take a minus outside and then write down 20s minus 1. Although there is a pole in RHP, but still take minus outside. So this minus minus will cancel, and then you have 1 upon 2s into 20s minus 1. Okay, now do the analysis. Now do the analysis. Okay, see, starting angle theta st minus 90 degree into n is 1, so minus 90 degree, minus 90 degree, negative y axis. Diving angle, okay, no, there is a pole in RHP, sorry, there is a RHP pole, so starting angle formula will change. Starting angle formula, RHP pole means the starting angle will reduce by 180 degree. So it is minus 270 degree, means positive y. Positive y. Then diving angle minus 90 degree into p minus z. Total poles are 2 and there are no zeros. So diving has to be minus 180 degree. Minus 180 means negative real axis, negative x axis. Okay, so you see, diving means infinity and negative real axis. So see, definitely this is wrong, because this is positive real axis. Okay, these two are wrong. Okay, now very clearly you see the diving is here. Correct answer is B. You know, you are able to see this is also wrong, positive y axis. I want to dive along negative x axis. That is why, you know, this approach starting and diving, especially for MCQ, it will simply give you quick answer, tick mark. Okay, tick mark. So what is there? Negative real axis. So diving along negative real axis is there only in the option B or D. Correct, na? It is only in the option B or D, where I am coming along negative real axis. But see, what is wrong here is the arrow, the omega equal to 0. Now what is 0? Positive y axis. Okay, positive y axis. Okay, this is wrong. So this is 1. Okay, this is B because of theta starting. Theta starting is minus 270. That is there in the B option. Okay, the starting has to be along positive y axis. This is starting, okay, which is along negative y axis. This is wrong. Okay, the B answer. B answer. That's why I told you many a time, especially in MCQ. See, some previous questions we have done completely, because many times a complete question, a conventional question will teach you a lot. But when you come to business, like when you come to the gate question, many a times only that starting and diving angle calculation I told you will help you tick mark the answer. That's it. Finished. Okay, answer is B. Answer is B. Answer is B. No critical frequency is coming, as you can see in the plot also. Think why no critical frequency? Because if you elaborate the phase expression, this will have how much phase? Pure imaginary, 90 degree. So there is only one tan inverse term. There is only one tan inverse term, and critical frequency I told you is possible when you have multiple tan inverse term. When you simplify them and you get some critical frequency. Critical frequency, remember, is again possible only for 2 or more tan inverse term. Correct? For 2 or more tan inverse term. Okay, 7th one done. Okay, so now next important update. I just few moments ago I updated about the offline course, but in case you cannot travel to Hyderabad for offline, or if you're a college going student cannot daily attend offline, so you can still prepare for GATE 27 and 28 under the guidance of Home Institute, same faculty team. So the first offline course, sorry, the first online course, this is about online one. Okay, so the first online course starts 2nd February. The first online course for GATE 27-28 starts 2nd February. Okay, the fee for 1 year, the online courses available for both GATE 27 and 28 with 1 year or 2 year validity respectively. Okay, important point is till 20th January there is a early bird discount. If you register till 20th January, you get an additional 20% discount, and at the same time 1 month extra validity. 1 month extra validity. You just have to use the code OMGATE20. Okay. Yeah, next one. Now see a foundation question. The open loop part, the open loop transfer function should be mentioned, something like that. Okay, the open loop of a system, open loop gain of a unity feedback system, GS. Okay, open loop in GSHS, but unity feedback is mentioned. So that means only GS is unstable. Okay, and has two poles on the right side of the S plane. Now, number of poles of GS on the right side is known as what? Okay, has two poles on the right side. That means this information is about P plus. Correct, na? However, the closed loop system is stable. See, it's a language based understanding question. Okay, however, the closed loop system is stable. Okay, closed loop system is stable means zeros of characteristic equation is nil. This is easy, but I have seen sometimes students doing this wrong. Language they are not able to understand. See, so what does this question say? P plus 2 and Z plus 0. The number of encirclements made by the Nyquist plot of the -1, 0 point. Okay, so number of encirclement P plus minus Z plus will be 2 minus 0, that is 2. Okay, that is 2. Correct answer A. Correct answer A. Now see, in this question, there is no information. In this question, there is no information about Nyquist contour. Okay, so why not Z minus P? Because if you do Z minus P, you will get the answer -2 not available. Simple logic. If I have to use the reverse formula Z minus P, that is not available in the option. So, okay, forget. Okay, so correct answer is 2. Next question. Okay, yeah, now when Nyquist plot is given, the Nyquist plot of an open loop transfer function of a negative feedback control system is shown. Now, important, see the languages. Open loop system is stable. Open loop system is stable. Okay. Yeah, that is by default also you can take Samuka, or if you try the other one also, I told you, na, if you randomly try, -2 is not in the option. Now see, if the open loop system is stable, how is any system stable? If any system is stable, it should not have RHP poles. Okay, open loop system is stable means what? This statement simply means no RHP poles of the open loop transfer function, and RHP poles of open loop transfer function is P plus, no poles means P plus is 0. That is the information. Okay, now what about the closed loop? Now very clearly you see -1 indicated here. Is it encircled? Is the -1 encircled? Now see, if I trace now, see, if I just trace it, have a look with me. Just look with me. I'll start this. This is one encirclement complete. Okay, one 360-degree rotated na, from x-axis to x-axis. Okay, so one encirclement. What direction I went? I went clockwise. Okay, now continuing from here. One more encirclement complete. Two encirclement. Okay, both in the clockwise sense. Two encirclements I have completed. Both are in the clockwise sense. Okay, so this point has been encircled how many times? Twice. Okay, the value of n is 2 clockwise, means -2. Means -2. Okay, so again, n, assuming the clockwise Nyquist contour, n equal to P plus minus Z plus. What is n? Is -2 equal to P plus 0 minus Z plus. Okay, so what is Z plus? Is 2. Z plus is not 0, means system is unstable. So it is unstable with how many, RHP poles? With 2 RHP poles. Option number A. Option number A. It is unstable with 2 RHP poles. It is simply unstable with 2 RHP poles. Okay. Now see again, dear, I want to keep telling you. Suppose if you tried this formula, no information about contour is given. You will see some question where contour information is given. But if I tried this formula, Z minus P anti-clockwise Nyquist contour. This is clockwise. If I tried this formula, what is the n value? -2 equal to Z plus minus P plus. But if I tried this, what is the Z plus? -2. Not possible. Not possible, because see, Z plus is a count. How many poles of the closed loop system lie in the RHP? It may be 0 or 1 or 2. That count cannot be negative, na? That count cannot be negative. It is number, it is quantity something. Okay, so Z plus equal to negative. Not possible. This data na P plus. See, n has a sign convention. N may be positive, negative, but P plus or Z plus alone has to be positive. They cannot be negative. They are counts. Okay, so now you understood why this cannot be taken in this question. Okay, right? Right. Next question, number 10. The pole zero map, MSQ question, and the Nyquist plot of the open loop transfer function GSHS of a feedback system are shown for this system. Now see, the pole zero map of what? Of the open loop transfer function. Okay, pole zero map is given. Okay, there are 2 zeros in RHP, okay, and 3 poles in LHP. Okay, that means for this is the pole zero plot for GSHS, which has all poles in LHP. Okay, so what is the P plus is 0, and all poles in LHP means stable. Okay, stable. What is stable? GSHS. This is the pole zero map of GSHS. So open loop system is stable. Open loop system is stable. Okay. Okay. What about closed loop? What about the closed loop? Now, for closed loop, I want, okay, for closed loop, what I want, okay, I want the number of encirclement. Now you see here, number of encirclement, 1 clockwise, 2 clockwise. Very clearly, both are clockwise. Very clearly, both are clockwise. So, number of encirclement, n is equal to 2 clockwise, meaning minus 2. Okay, again, let me try n equal to p plus minus z plus. N is minus 2. P plus is how much? 0 minus z plus. So, z plus equal to 2. Okay, z plus is not equal to 0 means the closed loop is unstable. Correct. Okay, the closed loop has how many poles in the RHP? It has 2 RHP poles. Correct. Okay, so A, B, C, 3 answers correct. MSQ question it is A, B, C. A, B, C. Okay, Samuka, if you said A and C with C, automatically B is correct. Na? 2 RHP poles means unstable only. Na? Correct. A, B, C. 3 answers correct for this MSQ question. Next question. Now, next logic. See here, important one. Okay, see here, important one. Yes, Harsh correct ABC, Samukha now correct ABC. Right? Okay, now please see here. Consider the standard negative feedback configuration. GS and HS both are given. The number of clockwise encirclements of -1, 0 in the Nyquist plot. The question is how many times -1, 0 is encircled? How many times -1, 0 is encircled? Okay, normally what people think here, if I have to get the encirclements of -1, 0 by the Nyquist plot, I will have to first draw the Nyquist plot. What people think here, I will have to first draw the Nyquist plot, but I will tell you not required. I will tell you not required. Drawing the Nyquist plot for this function will take time. Okay, simply use the formula. Now, what is n? N is p plus minus z plus. N is p plus minus z plus. Do I know p plus and z plus? Do I know p plus and z plus? Now you see here. Okay. Do I know p plus and z plus? Yes, I can know it. What is GS? Okay. What is GS? S square plus 0.2s plus 100 divided by s square minus 0.2s plus 100. Okay, what are the poles? What are the poles of GSHS? What are the poles of GSHS? No problem. Let me multiply HS also. HS is 1 by 2, na? Okay, but what are the poles? You will equate the denominator to 0 and you will get 0.2 minus B plus minus root over B square minus 4AC divided by 2A. This is going to be negative. That means, what are the poles, dear? That means 0.2 by 2 is 0.1 plus minus negative, j of something. Okay, but the real part is positive in nature. And if the real part is positive in nature, that means both of them are RHP. Both of them are in RHP. Okay, so if there are 2 poles in RHP, so P plus is equal to 2. P plus equal to 2. Okay, because what is P plus? Poles of GSHS. Okay, next what I need to complete the question? Z plus. Okay, what is Z plus? What is Z plus? Number of zeros of what? Zeros of characteristic equation actually. Okay, where not all zeros, RHP zeros of characteristic equation. So let me form that characteristic equation. 1 plus GSHS, 1 plus 1 by 2 S square plus 0.2S plus 100 upon S square minus of 0.2s plus 100 equal to 0. This is the characteristic equation. So when I solve it, I'll have 2s square plus s square. Total 3s square will come. 2 into minus 0.2 minus 0.4 plus 0.2. So minus 0.2s plus 2 into 100 plus 1 into 100, 300. Okay, correct. Just keep checking the calculation. Dear, this is negative na. Okay, again when you solve, you will get minus b, that is 0.2 plus 0.2 plus minus again 0.2 square minus 4ac. Okay, sorry. Okay, yeah. So this time when you solve for 4ac, this is going to be 433, some 3600 divided by 2 into 3. Okay, that means, okay, 0.2 by the 0.1 by 3 plus minus j again something. Positive real part means RHP. Okay, again RHP. Okay, now number of zeros in RHP itself is known as the Z plus. So Z plus is 2. Okay, P plus was 2. So what is the N value? What is the N value? Now P plus minus Z plus. Again, Nyquist contour not mentioned. Okay, again Nyquist contour not mentioned. N equal to P plus minus Z plus or Z plus minus P plus. But both are same na. So N will be 0. So here again Nyquist contour is not required. Okay, because P plus minus Z plus or Z plus minus P plus. Okay, anything. If not mentioned, by default we start taking clockwise, but I think some questions will mention also when required. But here answer is 0, P plus and Z plus. So see, this is a question on just knowing the idea of Nyquist plot, not drawing the Nyquist plot. Just a basic characteristic equation, some basic quadratic calculations are required. Understand this theme of question. Important, okay? Don't start drawing the Nyquist plot. Waste of time. That will be a big waste of time, okay? MSQ question. Choose the correct option. The Nyquist plot of GSHS equal to s minus 2 upon s plus 1 square. Okay. Now see, first and second option is number of right side poles of closed loop and open loop transfer function. Okay. That I can directly, GSHS given, I can do the calculations directly. And then will it encircle minus 1 comma 0 once or clockwise, once anti-clockwise? That I don't need to draw the Nyquist plot. Again, we'll follow the same approach like previous question. Okay. See. What is GSHS given? What is GSHS? S minus 2 upon S plus 1 square. Okay, what are the poles? Minus 1 repeated. Okay, both LHP. Both LHP. So, is there any RHP pole? No, 0. Okay. Z plus means I need the characteristic equation. What is the characteristic equation? 1 plus GSHS. 1 plus s minus 2 upon s plus 1 whole square equal to 0. So if I solve it, I'll get s square plus 2s plus s plus 3s plus 2 minus 2, 0. I think this should be left. S square, okay, plus 2s plus s plus 3s and plus 1 minus, sorry, not this one. S square plus 1 minus 2. So minus 1 will be left here. Okay. Let me recheck. S square, okay. Plus 1 and minus 2 minus 1, okay, and plus 2s plus s. Yeah, this is what is the characteristic equation going to be. Okay, so what are the roots here? Okay, minus 3 plus minus root over b square. Okay, that is 3 square. Okay, minus 4ac. So this will become plus 4 minus 4ac divided by 2 into 1. So this is minus 3 plus minus under root of 13 by 2. Now minus 3 minus root 13. LHP, but minus 3 plus root 13. Root 13 is greater than 3. Okay, so this will have 1 LHP, 1 RHP. 1 LHP, 1 RHP. 1 LHP, 1 RHP. When you solve for the, or don't solve, you can just guess it. Na? Okay, one will be pure LHP, one will be RHP. That means what is the value of Z plus? What is the value of Z plus 1? 1 in RHP. Okay, so the number of right side poles of closed loop transfer function is 1. What is Z plus? Roots of characteristic equation, also known as poles of closed loop transfer function. Yes, A option correct. Why? Because this is Z plus, which is 1. The number of right side poles of open loop transfer function, which is P plus, is 0. So B answer is not correct. B answer is not correct. It will encircle. Now, encirclement N equal to P plus minus Z plus. Now, I'll use the standard one. Okay, or I will write down again with the question. I think I should mention, assume clockwise Nyquist path. Okay, so then n will be how much? P plus is 0, z plus is 1. So n equal to minus 1. Minus 1 means 1 clockwise. Okay, so once clockwise, answer C, but for that Nyquist contour has to be mentioned as clockwise, or we will by default assume clockwise. But properly when they form the gate questions, they are very clear with the data. Okay, so they will mention somehow Nyquist contour data. So assume Nyquist contour as clockwise, then I'll use the formula P minus Z. Otherwise, if I use Z minus P, then I'll get 1. Then the plus 1 means anti-clockwise. Okay, but right now we'll take it as 1 clockwise. That is A and C are the correct answers. 2 questions, but actually we don't need, this is a question on Nyquist plot, but we don't need to draw the Nyquist plot. Okay. Number 13. Another MSQ question. See, a unity feedback system has the open loop transfer function given. The Nyquist plot of GS which encircle, now will encircle minus 1 comma 0 and will encircle the origin. There are 2 things given. There are 2 things given. Remember. First of all, what are the poles of GSHS? What are the poles of GSHS? S equal to minus 1 plus 2 plus 3. Minus 1 plus 2 plus 3. There are 2 RHP. There are 2 RHP poles. That means P plus value is 2. P plus value is 2. So remember dear, I told you 2 definitions in the beginning where P plus is common. Okay, but if you want the encirclement of origin, for 0, 0 encirclement, what is Z plus? Okay, first case. For 0, 0 encirclements, what is Z plus? Okay, Z plus is simply the zeros of GSHS. Only GSHS zeros. Okay, what is the GSHS here? HS is 1, unity feedback it is. And that is 1 plus 1 upon S plus 1, S minus 2, S minus 3. Okay, how many zeros in RHP? Okay, there are no zeros actually. There are no zeros. So this is 0. Okay, so now use the formula N equal to P plus minus Z plus. P plus is 2 and Z plus is 0. So what is the N? It is 2. Plus 2 means 2 anti-clockwise. So it will encircle the origin. It will encircle the origin 2 times. It does not encircle the origin, that is wrong. So A answer is correct, B is wrong. But then C and D are talking about encirclement minus 1 comma 0. Encirclement of minus. This is the point I told you in the beginning. Hope you remember it. Okay. This is the second point. Important one for stability actually. For minus 1 comma 0 encirclements. Okay. What is Z plus? Z plus is the number of zeros of 1 plus GSHS. That means characteristic equation roots. Zeros of 1 plus GSHS in RHP. How much it will be? So I will have to form this, na? I will form 1 plus GSHS equal to 0. 1 plus GSHS is anyways 1, S plus 2, S minus 2, S minus 3 equal to 0. Okay, now when you solve it, dear, you will get S cube. Then how much? Minus 2, minus 3, minus 5 plus 1. Minus 4s square. Minus 4s square. Then how much it will be? Let me write down the calculation here. Minus 2, minus 3 and plus 6. So that should be plus s. And then 1 into minus 2 minus 6. 6 plus 1, 7. Okay, cubic equation will come. Now, in this cubic equation, how many are in RHP? You don't have the calculator for cubic equations. Okay, so how many RHP poles? You will have to slightly apply Routh-Hurwitz. You will have to slightly apply the Routh-Hurwitz criteria here. You will have to apply the Routh-Hurwitz criteria here. Okay, S cube and S square. S cube 1 and 1. S square minus 4 and 7. Alternate coefficients minus 4 and 7. S power 1. Minus 4 minus 7. Minus 11. Minus 4 minus 7. Minus 11 by minus 4. Okay, minus 11 by minus 4 is nothing but 11 by 4. Positive only. Last element 0. S power 0. 11 by 4 into 7 divided by 11 by 4. 7 and 0. So are there sign changes? Yes. One sign change and one more sign change. Negative and then again positive. Okay, 2 sign changes. Okay, 2 sign changes means 2 RHP. Okay, so this equation will have 2 RHP roots. Okay, and by RH we got that Z plus equal to 2. Okay, so this value is 2. Okay, so now what is the N value here? P plus minus Z plus. Okay, P plus is 2, Z plus is 2, so that is 0. Okay, N is 0. Which encirclement? Minus 1 comma 0 will not be encircled. It does not encircle minus 1 comma 0. D answer. A and D. A and D. No, n equal to minus 1, Samukha, simply means that by the Nyquist plot, it does not give the information on Nyquist path. N equal to minus 1 tells that the Nyquist plot, whatever comes, will encircle the minus 1 comma 0 once in the clockwise sense. Okay. Yes, Nanindra, correct answer A and D. 2 answers correct for this MSQ question. Okay. 2 answers correct for this MSQ question. Next one. Number 14. A unity feedback system is given to me. Okay, it has the open loop transfer function k by s, s plus 1, s plus 5. For k equal to 3, the number of encirclements of the Nyquist plot around the point. Now see, this is a concept based question. It has nothing to do with stability, because stability means I want the encirclement of minus 1 plus 0, minus 1 plus j0. Okay, but whenever you want the encirclement of minus 2 comma 0, okay, if you want the encirclement of minus 2 comma 0, see, I'll tell you here once again, P plus will be fixed. P plus is number of poles. It's a good question, concept tester, number of poles of GSHS only. Okay, in RHP. Okay, in RHP. Okay, now whenever you want 0, 0 encirclement, okay, when you want 0, 0 encirclement, then Z plus is what? Number of zeros of GSHS only, correct? In RHP. When you wanted the encirclement of minus 1 comma 0, then what is Z plus? Number of zeros of 1 plus GSHS. In RHP. When you want the encirclement of minus 2 comma 0, what will be Z plus? It will be the zeros of 2 plus GSHS. Some random equation you have to solve, 2 plus GSHS, and write down its root in RHP. Okay, what is P plus for this question? Okay, what are the poles here? 0, minus 1, minus 5. So P plus is 0 here. Okay, P plus is 0. Then I want the zeros of 2 plus GSHS. Okay, what is the equation 2 plus GSHS? Equal to 0. I want the zeros of this equation. Okay, that is 2 plus k. K will be 3. They have clearly mentioned k equal to 3 upon s, s plus 1, s plus 5 equal to 0. So it will become 2, then s cube will come. And then 1 plus 5, 6. So 2, 6 into 2, 12 s square. Next will be 1 into 5, 5, 5s into 2, 10s plus 3 equal to 0. Okay. Now, again, because it's a cubic equation, you will have to apply RH criteria. S cube, S square. The alternate coefficients are 2 and 10, 12 and 3. S power 1. This is 120 and minus 6, 114 divided by 12. This is 0. S power 0 x into 3 by x. This is 3. Okay, no sign change. Okay, no sign change. That means no RHP root. Okay, no RHP root. So Z plus will be 0 because I want the zeros of GSH, 2 plus GSHS in RHP. So that is 0. P plus also 0. Okay, so what is the value of N? The value of N will be P plus minus Z plus, that is 0 minus 0, and that will be 0. Yeah, 1 plus GSHS equal to minus 1 is same as 2 plus GSHS, Harsh. Correct, na? That's what. That is what is the concept you want to add it. Correct, Shamuka. Yes, Shadow, correct. Origin shifted by minus 2. Okay. Okay, but yeah, as a concept and as a mathematical foundation, you should be ready for such question also. Not about stability, but general concept of encirclements by the Nyquist plot, encirclement of 0, 0, minus 1, 0, minus 2, comma 0, or etc. Correct? Yeah. Chalo. So good question it is. Number 15th, here it is. Which of the following is the transfer function of a system having the Nyquist plot shown in the figure below? Come on. Now let's have a look into this one. Let us have a look into this one. Okay, Nyquist plot shown in the figure. For the Nyquist plot shown in the figure. Now see here, how I can quickly guess. Let me look into this diving angle. Let me look into the infinity plus. Infinity plus means diving into origin, and diving into origin is along positive real axis. Okay, that is 0 degree. Okay, that is minus 90 degree into P minus Z is 0. So that means P must be Z. Number of poles and zeros are equal. Okay. Positive real axis. Number of poles and zeros are equal, but that I possibly don't see in any answer. Minus 90 into P minus Z. Okay. Is there any error here? Otherwise, it's not going to come up. Or otherwise, so this is definitely not true because none of the option has P equal to Z. But yeah, one more thing. Okay, 0 degree is also equal to 360 degree. Remember, 0 degree is also 360 degree if the answer is not matching by 0. Why? Because even if you take a 360 degree rotation, you come back to positive x-axis. Okay, so minus 90 into P minus Z is 0 or 360 degree. Minus 360 because this is starting with minus. So P minus Z, okay, what can be the correct information that I can collect for P minus Z? P minus Z is either 0 or 4. It may be 0 or 4. So 0 is not possible. Okay, the difference between pole and 0, 4, that is definitely possible in some options. Okay, now look into the starting angle. How it is starting? Sorry, not 0 minus, 0 plus, positive frequency part. Okay, the starting angle is shown to be parallel to negative real axis, that is minus 180 degree. And the starting angle is minus 90 degree into N. Okay, there is no RHP pole and 0 in the option. So minus 90 into N. So this clearly says N equal to 2. Okay, N equal to 2. So N equal to 2. Now see, we have two information. If I talk with N equal to 2, okay, if I talk with N equal to 2, that is there in the three options, B, C or D. Okay, number of poles at origin. But P minus Z equal to 0 is not there in any option. P minus Z equal to 4. Okay, so difference between pole and 0. See, these are 4 poles and 1 0, wrong. 4 poles and 2 0, wrong. 4 poles and no 0. This will be only there in option number B. These have come down over. This is A, B. This will only be option number B. Okay, option number B, this one. This one. Got it? Got it? One, two, three, four, and 2. No, correct. Yeah. B correct. Yes, shadow, B correct, not D. Okay. So basic analysis question. Again, see how I solved the question. Starting and diving angle, enough. Starting and diving angle, enough to complete the question. Starting and diving angle is enough to complete the question. Yes, Jnanendra, correct. Okay. So while sketching and while analysis, both the case, the starting and diving will help you. Okay, only thing is be careful about any pole or 0 in RHP. There is no RHP pole or 0. It's a minimum phase case. So starting angle formula remains to be same. Otherwise, the change also I have told you. Na? Next question. Number 17th. Okay, the polar diagram is given of a conditionally stable system. Okay, for the open loop given k equal to 1 is shown in the figure. The open loop transfer function of the system is known to be stable. What is the meaning of this statement? Open loop transfer function is stable means open loop system will not have any pole in RHP, and RHP poles of open loop system is known as P plus. So what is going to be the value for P plus? Is going to be 0. Clear enough? Okay, that's going to be 0. What about the closed loop system? Okay, now closed loop system is stable. Now it's an important question. It's stable for what values of k? Now this is only polar diagram. Let's complete into the Nyquist diagram. Let's complete this into the Nyquist diagram. Now see here. Okay, mirror image of the polar plot will be taken. Number 1. Mirror image of the polar plot about x-axis. Okay, so we should always know that diving means infinity, na? So this is infinity plus, image infinity minus. If this was diving given, this has to be 0 plus, other one. So this automatically becomes image 0 minus. Now 0 minus to 0 plus. Just simply join the 0 minus to 0 plus. But one important thing is 0 minus to 0 plus, by how much angle you will join? By how much angle you will join? See here, I'll tell you that also. I'll tell you that this is infinity plus, this is 0 plus. 0 plus means what is the starting? negative y-axis. The starting is along negative y-axis. Negative y-axis is minus 90 degree. Okay, the minus 90 degree into n is minus 90 degree. Okay, I see here starting is minus 90, which has to be compared as minus 90 into n. So n is 1. So now dear, if n is 1, so here you can write down the closing angle also. What is the closing angle? N pi, that is pi clockwise. Closing angle is pi clockwise. So from here, okay, 0 minus to 0 plus clockwise. Okay, 180 degree means one semicircle is required, this much. This is the complete Nyquist plot. Okay, now P plus is 0. What is the condition for the closed loop system to be stable? Closed loop system is stable if Z plus is 0. Closed loop system is stable if Z plus is 0. So what about the N you want? N is P plus minus Z plus, and that also will be 0. Or whether Z minus P. Anyways, the N will be 0. Clear? The N has to be 0. That means no encirclements. No net encirclement. Okay, but where is minus 1 comma 0? Okay, simple. Case number 1, it is outside. So no encirclement. Okay, now let me complete the arrows also. Okay, infinity minus to 0 minus. Zero minus to 0 plus. And 0 plus to infinity plus. Okay, so now the second possibility is, now see, n equal to 0 does not always means no encirclement. It means no net encirclement. See, I'll tell you what is the meaning of this statement. See, if you come here, okay, case number 2, minus 1 comma 0. Okay, so encirclement, one clockwise, one more clockwise. Okay, I'll write down case by case. In case number 1, no encirclement. It is outside only. Case number 1, there are two clockwise encirclement. So I don't want any encirclement. Case number 3. Okay, case number 3. I will, there are different portions. I will place minus 1 comma 0 here. Now, when you place minus 1 comma 0 here, one anti-clockwise, one clockwise. That is what I mean by net encirclement. N is one clockwise and one anti-clockwise. In the case number 3, are you able to follow? You see here once with me. You see with me once. Okay, this is one anti-clockwise. Okay, and one more clockwise rotation around this point. Okay, one clockwise, one anti-clockwise. One clockwise, one anti-clockwise. Okay, anti-clockwise by the small loop. Okay, and clockwise by the outer loop. Okay, correct. So what is the net value of n? The net value of n, minus 1 plus 1 is 0. So n equal to 0 means net encirclement 0. One positive and one negative may cancel also. And then, of course, what will be the case number 4? This is fourth. Okay, minus 1 comma 0 here. So in the fourth case, okay, the value of n, okay, again, one clockwise, one more outer, one clockwise. It is two clockwise, minus 2. Two clockwise means minus 2. Okay, so I want n equal to 0. Okay, that means case number 1 and case number 3. So for case number 1, what is the condition? Okay, case number 1 means that this distance 1, this much distance 1 is greater than this distance. Acha, one more point. This is the diagram for k equal to 1. Okay, if I generally take any gain k, all the magnitudes will be multiplied by k. Okay, so this point will actually be, now minus 8k. This point will be minus 2k and this will be minus 0.2k. That means how much is this distance? 8k. So 1 has to be greater than 8k because 1 is outside now. 1 should be bigger than this much of the distance. Okay, so k less than 1 by 8. Okay, and then I want case number 3. Okay, I want case number 3. So case number 3 will be possible. I'll write down the details of case number 3 here separately. Case number 3. So 1 is in this case number 3. That means this distance 1 is less than what? 2k. 1 is less than 2k. And at the same time, this much distance, 1 should be greater than this distance, 0.2k. 1 should be greater than 0.2k. Okay, so 1 is less than 2k means k actually greater than half. And 1 greater than 0.2k actually means k less than 1 upon 0.2, k less than 5. Okay, so this tells you that k is between 1 by 2 to 5. Okay, 1 by 2 to 5. Okay, right. And in the case number 1, already I told you k less than 1 by 8. Okay, so n equal to 0, n equal to 0 will happen in case 1 and case number 3. The details are on the next slide. 1 by 2 to 5 is case number 3, and k, how much we got? Less than 1 by 8. Less than 1 by 8. Okay. These are the two cases I want. Minus 1 comma 0 case number 1, minus 1 comma 0 here in case number 3. Okay, so k less than 1 by 8 and 1 by 2 to 5. These are the two possible ranges. Option number B. Option number B. Correct, Harsh. We need to multiply all the points by k because this was a diagram for k equal to 1 clearly mentioned. Okay. These are all important questions. Next question. This was 16th. Number 17th. Here it is. The Nyquist plot of a system for omega equal to 0 to infinity. That means Nyquist plot for omega equal to 0 to infinity simply means polar plot only. Okay. For k equal to 10. Now, this time the plot has been shown for k 10. Okay. If there is no open loop poles and zeros in the right half of the S-plane. Okay. No open loop poles. This is important. In the right half of the S-plane. That means P plus is 0. Okay. Then for stability of the system, which of the following option is correct? Again, stability of the system requires Z plus equal to 0. Okay. So what is N? N is P plus minus Z plus. Okay, P plus is also 0, Z plus is also 0. So again, I want no net encirclement. Okay, but this is polar diagram. This is polar diagram and this is the polar diagram for K10. So what is the polar diagram for K equal to 1? You divide by 10. You divide by 10 means this point. Okay, or first let me complete the diagram and then I will write down these calculations. Okay, how to complete the diagram? Mirror image. About horizontal. Okay, if this is 0, 0 means 0 plus, infinity means infinity plus. So this will be infinity minus, this will be 0 minus. Then we will draw the rest of the thing. Okay, but before that, this is minus 5 by 10. This was for K10. So minus 5 by 10 and then into K for any gain K. So this is actually minus K by 2 or 0.5K. You can write down this as minus 0.5K. Similarly, how much will be this point now? Okay, minus 0.1 divide by 10 into gain K. So this is minus 0.01K, this particular point. Okay. Right. Now 0 minus to 0 plus. How much angle? 0 minus to 0 plus. How much angle? Now you see here again, I will go to this point. Okay. How much is the starting angle? Positive y-axis. Positive y-axis means minus 270. So that means minus 90 degree into n equal to 3. Starting angle is minus 90 degree into n. So n will be 3 here because positive y-axis na. Okay, n equal to 3. So if n equal to 3, how much is the closing angle? Closing angle is, okay, 3 pi. 3 pi clockwise. Closing angle is 3 pi. So from here, okay, you have to start 0 minus and go clockwise, but 3 times pi. 1 pi is 180 degree, means 3 semicircles. So, and that too clockwise. See, if I go this way, it becomes anti-clockwise. So how actually I will go? I have to go clockwise. Okay, this is 180 complete. Okay, this is actually 360 complete. Okay, and let me complete with the arrow. Infinity minus to 0 minus. Now from 0 minus. Okay, so one full circle and one half circle, one semicircle. Okay, from 0 minus I come to 0 plus, and from 0 plus finally I come to infinity plus. Okay, all right. So again there will be 2-3 cases. Okay, one case here minus 1 comma 0, this portion, case number 1. case number 2 for minus 1 comma 0, and case number 3 here for minus 1 comma 0. Okay, in the case number 1, okay, how many encirclement? Okay, how many encirclement? There is an encirclement. I want no net encirclement. Okay, so how many encirclement here? I will show you this way. See, infinity minus 2, 0 minus. This is not relevant, but from here, see this. If you trace this much, okay, one rotation complete, na? One rotation is complete by this much only. Okay, and then if you come back, another will not be complete, but one rotation is complete in the clockwise. One rotation is complete in the clockwise. N equal to 1 clockwise. That means n is minus 1. I don't want n minus 1. Case number 2. Now, case number 2, you can clearly see one anti-clockwise and one clockwise. Okay. One clockwise and one anti-clockwise. Okay. So, that means n equal to minus 1 plus 1 will be 0. And case number 3, again one clockwise and one more the outer one clockwise. So, n will be 2 clockwise actually. Case number 3, n will be 2 clockwise. So, n is actually minus 2. Okay. So, I want n equal to 0. N equal to 0 for case 2 only. Okay. This is what was required for stability. N equal to 0 for stability, because z plus and p plus are both 0. Okay. So, I want case number 2. Now, what is the condition for case number 2? This magnitude 1 should be greater than 0.01 K. 1 should be greater than 0.01 K, and this distance 1 should be less than how much? Less than how much? Less than 0.5 K. Less than 0.5 K. That means here K will be less than 100 and here K will be greater than 1 upon 0.5, 2. Okay. So, K is greater than 2 but less than 100. So, 2 is less than the K is less than 100. Good question. Especially that closing angle you have to take care, be careful. Okay. So, 2 to 100. How much angle is required for closing? Answer is 2 to 100. D answer. Okay. Next question. Okay. Yeah, guys, before the next question, next important update for all of you. Yes, if you or your friends are planning for the AE preparation for Telangana Genco Transco Discoms or for AP Genco Transco Discoms, the new offline batch again at our Hyderabad center starts 21st January. Okay, for Genco Transco and Discoms exam. All right. Now, at the end, I also wanted to discuss some gate questions. This is very similar to the previous question. See, a closed loop control system with unity negative feedback and KGS and the forward path where the gain K is 2. Okay, where the gain K is 2. Nyquist plot of transfer function GS is shown. Okay, note that the Nyquist contour, very clearly mentioned, Nyquist contour has been chosen to be clockwise sense. They have clearly mentioned here. Assume GS has no poles. Okay, assume GS has no poles on the closed right half of the complex plane. GS, no poles in the right side. That means P plus is 0. Okay, the number of poles of closed loop transfer function in the right half. So that means I want Z plus. I want the value of Z plus. Right, I want the Z plus. Okay, for what encirclement? For minus 1 comma 0 encirclements. But this is the Nyquist plot shown. Okay, for the gain K equal to 2. Now, this is the Nyquist plot only for GS, but actual system will have KGS in the forward path where K is 2. So, you have to consider the actual system where the Nyquist plot has to be taken as Nyquist plot of 2GS. This is the Nyquist plot of only GS. So, this is simple. 2GS means simply multiply by 2. So, this 0.4 will be 0.8. This 0.8 will be 1.6. Correct? Correct? So, now if this is 1.6, automatically the minus 1, now you know the fixed location, minus 1 will be between this 0.8 and 1.6. This will be minus 1 comma 0 modified for 2GS. Okay, so this has to be the Nyquist plot for 2GS. Okay, now very clearly, -1, 0 is encircled here. Once clockwise, one more time clockwise. It is encircled twice in the clockwise sense, that is -2. Okay, so what is the n formula you have to use? P plus minus Z plus, because the Nyquist contour is assumed to be clockwise. I told you, GATE, they will be more specific with the data when they form the actual question. Okay, so -2 is P plus minus Z plus. P plus was 0, so Z plus equal to 2. The question was Z plus and answer is 2. And answer is 2. Option number C, MCQ question. Right. Tell me any doubt. The Nyquist plot of a strictly stable GS having the numerator polynomial as S minus 3 encircles the critical point -1 once in the anti-clockwise direction. Which of the following statements on the closed loop system shown in the figure is correct? A GATE 25 basic question. The Nyquist plot of a strictly stable GS. Now, GS is stable. Any function is stable if it does not have RHP poles. So, P plus is 0. It has the numerator polynomial S minus 3. It encircles the critical point -1 once in the anti-clockwise direction. That means n equal to +1. Okay, which of the following statement of the closed loop system shown in the figure is correct? Okay, is correct. Now, see here. The numerator polynomial is given for GS, but whether that is required or not, we'll see. Okay. What is the formula? N equal to P plus minus Z plus. N equal to P plus minus Z plus if anti-clockwise contour is assumed. For anti-clockwise contour. Okay, but what is N? N equal to 1. P plus is 0 minus Z plus. Z plus is -1, and I told you the negative count not possible. So this is a wrong assumption. So Nyquist contour, sorry, this was clockwise contour. So Nyquist contour, you have to assume anti-clockwise. Anti-clockwise contour. Anti-clockwise Nyquist contour. Anti-clockwise Nyquist contour. N equal to Z minus P. What is N is 1 equal to Z plus minus P plus, and P plus is 0. So what is the Z plus is 1. Okay, see, if here also some valid value of Z plus is coming, then I can say I cannot say the value of Z plus because contour information is missing. Okay, then cannot be determined, something like that will come. Okay, but Z plus equal to 1. Okay, this is anyways not possible. So only possibility is Z plus equal to 1, and if Z plus is non-zero, that means system is unstable. That means system is unstable. System is unstable. Yeah. Stability can be determined and the system is unstable. D answer. Okay, D answer. GATE 25, 1 mark question. Question number 20. A unity feedback control system is characterized by the open loop transfer function. The Nyquist path and the corresponding, now you see, Nyquist path is shown. What is the Nyquist path? Very clearly you see. Okay, clockwise Nyquist path. And then the corresponding Nyquist plot, the other one is Nyquist plot, is shown in the figure. Okay. If k is between 0 to 1, number of poles of the closed loop transfer function that lie in the right half. Now let's be smart in this question. This is a very smart question because method number 1, okay, solve using the Nyquist plot. Okay, you try using the Nyquist plot. I'll give you that as homework. Method number 2. See, other questions, they are giving some information on GS. It is stable or it has these many poles in the RHP or something. This question has given GSHS. This question has given GSHS. Okay, so you can simply form the characteristic equation and directly solve the question by Routh-Hurwitz. Finish. Not required anything. Not required anything for this question. What is the characteristic equation? 1 plus GSHS. What was GSHS given? Let me see here. 10k s plus 2 upon 10k s plus 2. I told you this in the very beginning. If GSHS completely given, then stability we can determine our choice, Nyquist plot or RH. Okay, but directly you can go by RH. There will be a little difficulty in solving this question by Nyquist. Not impossible. Okay, but little bit more time taking. Oh, yeah, once you solve this, that is the homework for you. You will understand. Okay, so you will get S cube plus 3s square plus 2, or let me write down the S coefficient first. So plus 10k S will come, then plus 2 plus 20k. 2 plus 20k. This is equal to 0. Okay, what you want? K is between 0 to 1. Number of poles of closed loop transfer function is number of sign changes in the Routh array. Number of sign changes in the Routh array. I have S cube and S square here, 1 and 10k. Okay, 3 and 2 plus 20k. What is the S power 1? Okay, 30k and S 20k, that will be 10k and minus 2. No, I 100% sense there is some typo error in the question. 30k minus 20k, 10k minus 20, then it should be actually I think the question, this is plus 10 only. This is not 2, this should be 10. 2 is in the numerator, this should be 10. Okay, there was a typo error in this question. This is 10. Okay, so then this will become 10 plus 20k. Okay, so if I write down 10 here, then I'll get 30k minus 20k, that is 10k minus 10. Yeah, now it makes sense. It will be actually 10k minus 10 here, then divide by 3, last element of a row 0. This is 10 plus 20k, something like this, and 0. Okay, but you see here, what is mentioned for k? Okay, the k is between 0 to 1, important data. Because k is between 0 to 1, this is going to be negative. This is negative because k is less than 1. K is less than 1. So 10k is less than 10. Okay, if 10k less than 10, when you subtract, you get negative. This is again positive because k is positive. Okay, so you have positive to negative and again negative to positive. This one will be positive only. Okay, so 2 sign changes. Okay, that means 2 RHP poles of closed loop transfer function. 2 sign changes means 2 RHP poles of the closed loop transfer function. 2 RHP poles of the closed loop transfer function. Number of poles of the closed loop transfer function will be 2. You can directly solve by RH. But I want you to solve by Nyquist and see how do you get the answer by Nyquist. Okay, you will have to use a one important concept here. It's not going to be that direct, but that's why I want to give it as homework. Many questions out of concept we have solved. You should be able to solve it. Next one, the complete Nyquist plot, grade 21, very good question again as far as concept is concerned. The complete Nyquist plot of open loop transfer function GSHS of a feedback system is shown in the figure. If GSHS has 1, 0, if GSHS has 1, 0 in the right half of the S plane, but zeros of GSHS is not required for stability. Na? The number of poles of closed loop system, okay, in the right half, okay, poles of closed loop system, okay, Z plus, but poles of closed loop system, okay, are determined by using encirclement of which point? -1, 0. Okay, P plus is not given in the question. There is no information on P plus. Okay, now see, -1, 0. Look into this diagram. Okay, look into this diagram. -1, 0. Okay, 1 anti-clockwise, 1 clockwise, very clearly. So if you talk about -1, 0, okay, that is encircled 2 times. Sorry, that is encircled, okay, 2 times, but 1 clockwise and 1 anti-clockwise. That's what I have shown. 1 anti-clockwise and then 1 clockwise. So n is -1 plus 1, that is 0. Okay, but n is actually given by P plus minus Z plus. Okay, n is 0. Okay, and that is P plus minus Z plus. Okay, so what is Z plus is equal to P plus, but what is the P plus? What is the P plus? There is no information on P plus. So this is a very smart question. There is no information on P plus. It is not even mentioned that GSHS is stable. Otherwise, many questions you saw mentioning GSHS as stable. Okay, so what will I now do is, okay, let us talk about the 0, 0 encirclement. Because P plus is same in both the definitions. If we talk about 0, 0 encirclement, okay, one clockwise, one more clockwise. Okay, one clockwise, one more clockwise. So encircle 2 times clockwise. So for 0, 0 encirclement, n is minus 2. So again, n is given by, okay, P plus minus Z plus. Now, when you talk about 0, 0 encirclement, what is Z plus? Z plus is zeros of GSHS, only the GSHS in RHP, and that is given to you. See here, that is why this statement, if GSHS has 1, 0 in the RHP, okay, that means this is given as 1. Okay, so what is the n value? Minus 2 is P plus minus Z plus. Z plus is 1. So what is the P plus? Is minus 1. Now again count negative, not possible. Okay, so what is this question suggesting? If I told you now, whenever count negative coming not possible, that means then you have to try the reverse contour. So this formula, okay, is using the clockwise Nyquist contour. If you use the clockwise Nyquist contour, this is the formula. Okay, so you will have to try this question with anti-clockwise. Many times I told you this point. Anti-clockwise Nyquist contour. Anti-clockwise Nyquist path. Okay. So first I will talk about 0, 0 encirclement. Okay, formula now to be used is Z minus P. Okay, 0, 0 encirclement came out to be minus 2. The data is already available. Okay, is equal to Z plus. What is Z plus? 1 minus P plus. So what is the P plus now? Will become 1 plus 2. This is 3. This is a valid data. P plus equal to 2. Now come to minus 1 comma 0 encirclement. Okay, again using the formula n equal to Z minus P. Okay, now for minus 1 comma 0 also, how many encirclements are there? 0. That we have already noted. So 0 equal to Z plus minus P plus. P plus is equal to 3. So final Z plus. Okay, for 0, 0 encirclement means what is Z plus? For 0, 0 encirclement, Z plus is the roots of characteristic equation, or also known as poles of closed loop transfer function. Where? In RHP. Plus means RHP only. Okay, so what is the correct answer? Correct answer is option number A. This is a very good conceptual question. Correct answer is A here. 3. Yes, Samuka, correct answer 3. Okay. This question is actually asking you indirectly to talk about encirclement of minus 1 comma 0 as well as 0 comma 0. As well as 0 comma 0. Both are required. This also required and this also required. Then only the question is complete and solvable. Okay, dear. Then only the question is complete and solvable. Okay, dear students. So this was the 21st question of the today's 21 series. I think it's been 2.5 hours or more than that of the session, but I wanted to take variety of model of question, and I think this session itself will be a sufficient one to revise and learn Nyquist plot through questions. Okay, but still I told you, if you want a complete concept, if you wanted the complete concept of Nyquist plot, okay, how the Nyquist plot is derived and I will just share the link with you. Okay, I have taken, it's available. That itself is again a 2-hour video. That again is a 2-hour video on the Ohm Institute channel only. Okay, but if you really want the complete conceptual understanding, you can go for that. Some 2-3 questions may be common there. Some 2-3 questions will be common there, but no problem. But that is okay. I am sharing you the link of that session. So those who want to go into the depth of Nyquist plot with the derivation, with the understanding of each and every basic thing, okay, you can, refer to this link. Okay, you can refer to this. Okay, so I will share you the PDF of this session. Okay, Shadow asking for Bode. Okay guys, let me know in the comment box if you are looking for a similar session for Bode plots as well. If you're looking for a similar session on Bode plots as well, you can let me know. Out of control system, tell me the next topic that you want, Bode or something, immediately tell me the next one. Okay, whether it is Bode or something, immediate next topic what you want. Similarly, I'll try to plan. Okay, because very soon marathons are also going to start. Okay, you'll get the update very soon, by tomorrow itself. The complete marathon sessions will start. Okay, but okay, yeah guys, I'll share you this PDF, but as you know, the PDFs are password protected, because those who are following the classes, those who are learning through the classes, then only the PDF is required for you. And password encircle. The password for today's PDF will be encircle. Encircle. Okay, the password for today's PDF will be encircle. ENCIRCLE. Okay, everything in small. Okay, password encircle. Okay, I'll share the PDF in my Telegram group. I'll share you the Telegram details as well. But once again, let me remind you that on the next Sunday, 25th of January, the OM online scholarship test, okay, for all the online courses of GATE 27 and 28, okay, is going to be conducted, containing fundamental subjects, just like for beginner students. But if you perform well, like rank 1 to 3, you get 100% scholarship. If you get rank 4 to 10, 60%. So there are multiple scholarship based on your performance. All you have to do is appear in the test. The test is free. The registration is also free, but mandatory. So please register using this QR code. Okay, the platform will be, app or web, anything, OM Live app or ominstitute.live. Okay, and appear next Sunday at 6 p.m. Okay, the GATE first offline course, okay, for GATE 27 for both EC and EE starts 26th February. Okay, the first online live course, okay, the first online live course, I'll add that details also first. Okay, on 2nd February. This is available for both GATE 27 and 28. That is 1 year and 2 year with the respective fees mentioned. But important point is, for live course, if you register till 20th January, 2020 January, you get additional 20% discount and a 1 month extra validity. Okay, that means a 1 year, 12 months program will become 13, 24 will become 25 automatically. Okay, if you're willing to prepare for the AE examinations, okay, Genco Transco Discoms for both Telangana or AP State, the new batch starts 21st January. This offline batch again at our Hyderabad center. All these are the important details. Thanks, and guys, this is where the PDF will be shared. Hope you are connected in my Telegram already. Otherwise, you can connect. So as I can see, Bode and state space analysis. This is what is the demand coming up majorly. Okay, I'll plan. In the next 2-3 days, the next session will come. Okay, in the next 2 to 3 days, you will get the next session. So that's why if you're not subscribed, be subscribed to the channel so that you get all the updates and you don't miss a session. You will be notified about each and everything. Okay. All right, this is Rakesh Talreja signing off. Bye bye. Thank you. Stay safe and take good care of yourself.